Hello, IT. Have you tried turning it off and on again?
Turn it off. I just turned it on. What's up, guy?
Bullshit, I can't hear you. Sound off like you got a pair.
And Potion, that's why I have trust issues. Oh, so many news stories tonight. Because we got a lot of leftovers from last week. Hey, the good news is everything's looking pretty sharp, huh? Make sure. Yeah. Everything's looking pretty good on the stream side. I shouldn't have said that. I shouldn't have done that. Nope, shouldn't have done that. Because now it's gonna die. Now it's gonna break. Hey, Chris. See how it works. Woo, there we go. Hey, everyone. Happy Wednesday. Whose fault is that? Me. It's always my fault. Yes, I love this shirt. 1.44 megabytes of raw power. Yeah. I am. I'm rocking the floppy. Oh, man. Well, I hope y'all are having a wonderful start to the week. I was actually kind of sick yesterday, unfortunately. I'm still watching YouTube. I'm not sure what is going on with it. The bitrate is fluctuating so much. They all are, man. What the hell is going on? I need to figure out what's up here. I think I know. I think I'm going to have to go re-network the computers again, which is going to suck. Hang on one second. Let me check something. Yeah, actually, it looks like it's doing fine. Okay, cool. Let's see. What do we got here? As far as news stories are concerned. By the way, I know y'all probably have all heard about this. I got to go find them real quick. Hang on. All the stuff happening between Hugging Face. Yeah, here's the Hugging Face one, and then here's the follow-up. Let me see. Okay. Kick's looking fine. Awesome. Let's see. Choco Poco malware targets researchers via Trojanized proof of concept exploits. Dude, that's a tale as old as time, man. Also, hey Dad, what's up, dude? Yeah. Choco Poco. That's a funny name. Hold on. Yeah, hiding malware and proof of concept exploits for various vulnerabilities is not new, as there's examples of threat actors posing as real security researchers and taking advantage of trending vulnerabilities to target vulnerability and penetration testers and low-skilled hackers. Yeah, so, targeting skitties. I was like, just don't get popped by it. Always read the code before you go run it. When is this from? From July. Good enough. I didn't hear about it. But this is something that I always consider as like, there's no new and emerging threat. This is always like an active threat. Dev. Like, anytime I have to go pull proof of concept code, I'm going to go read it. I'm going to go take a look at it first, just to make sure they didn't hide anything sketch inside there. It's in the dependencies and not in the proof of concept? Let's see. Hold on. If it's in the dependencies, let's see. So identify 7 proof of concepts on GitHub that distributed the Choco Poco and host exploits for ForwardWeb, Reactive Shell, yada yada. So research was found. Skytext was downloaded. Okay, hold on. I want to see where it is in the dependencies, though. Hold on. Let me just go to the source article. I should know better than to try and read Hacker News. Hacker News is just... it's just a pain. Ugh. You have lost minus 50 CSS points for this horrible page layout. Ah, here we go. Hold on. Here we go. I think this might. Let me see. So we started to review the code, its authors, and every dependency before executing anything. Precaution paid off. This proof of concept that was now deleted depended on an unfamiliar package named Frint. The repository owner, Ogenik, had created their GitHub account only 2 weeks earlier. That's another really big flag. If I'm getting sent, hey, come check out my POC, and the GitHub account is really new or really young, that's another big flag. All activity was set to private. Frint itself had appeared on PyPy just a month before, and even more curiously, depended on another package called Skytext. Oh, I wish I could see the proof of concept in here, because that's you actually brought up a good thing there, Deb. If you go load up a POC and it's got a buttload of dependencies, chances are, if it's not doing binary exploitation, then it doesn't need those. And hold on, where's the... I wish I could see the list of the dependency tree in there. Because, like, if somebody ever writes, like, a proof of concept in NPM or something, nah. Python, yeah, I can kind of see that. No, these were specifically malicious backdoored POCs, Potion. Let's see. Hold on, let me read through this quick. So, it's shipped with two weird dependencies, Frint and Skytext. So Skytext shipped only precompiled wheels. That's a big no-no. There are very few repositories I will ever trust precompiled wheels, and some fancy text display is not one of them. It promised beautiful and blazing fast terminal colors for Python. Don't give a shit. Strip it out. Let's see. Virus total reported 0 detections, which is interesting. Let's see. Things soon got truly colorful. So the PyInt gradient entry point decompiled into an obfuscated function featuring hash-based module checks, PEB walking, and several compressed XOR encrypted blobs hidden in the data section. At that point, our appreciation of beautiful terminal colors reached a whole new level, so we decided... phone a friend, phone a friend, phone a friend, phone a friend. Nice. This took a more interesting turn than I was thinking it was going to, Dev. All right, so the investigation stems from a dependency confusion tactic where a malicious Python package was added to the repository's requirements, effectively trojanizing the distributed POC. So the infection is triggered when the victim executes the pip install command to download and install POC for the external requirements. See, that's why I'm not down with the requirements.txt. I was sure you could actually probably do it in UV too, but still. Let's see. So the package first downloads to the target system, dependency installs the Skytext package, a dependency of Frint, and transitively gets installed during that setup. So a specific native library extension is loaded directly into system memory. The corrupted native library executes immediately when the proof of concept Python file runs. The execution process decrypts 5 small Python scripts using a custom algorithm and unique key, requiring the runtime context of a specific POC environment to succeed. Interesting. So one of the decrypted scripts functions as a downloader, retrieving a subsequent Python script from Mapbox. Very interesting. Yeah, that would... So I would hope to think I wouldn't fall for this for once. Hold on, what was the POC they were looking for? Let me see. So they were looking for a React to Shell, FortiWeb, and Avanti Sentry. Interesting. So they're looking for cutting edge POCs, and yet these guys are coming in and they're like, hey, by the way, we've got this thing with some weird dependencies. Yeah. Oh, thanks. I appreciate it. Yeah, this was interesting. Cool. Here, hold on. I'm going to throw that in the news thread just for future tracking purposes. So that is pretty neat. All right, let me see what else we've got in here. Let me see what these guys said. Because the Hacker News site is just abysmal. Let's see. So these guys said, a misconfigured server and 3 active campaigns fully exposed, 3 man-in-the-middle phishing operations. Let's see. So April 2026, Internet Scan flagged an open directory. Again, it's always an open directory, man. That's what caught the guys doing this, the WordPress Shellstorm stuff. I'm glad to help you get something off your to-do list there, Dev. It's always these guys running Python HTTP servers. Always. I was like, guys, I'm gonna hate myself for doing this. There's a simple way to go in and add authorization to your Python. I've done this before. I thought there was actually a simpler Python import to do this, but it's not long. And then at least, you might not have the bestest, the most securest, but you could go through and you can go through and add authorization to your simple Python web servers. I mean, just a simple login. Come on, man. Hey, Ford. Sup, dog? Let's see. So what do they have in that open directory? Threat actor was running an Evil Jinx-based man-in-the-middle phishing platform and a simple help remote management console. Nice. So the threat actors behind the infrastructure turned out to be surprisingly straightforward. Several artifacts left on the server produced pretty clear identification. This is what always gets me, guys. Look, so it says the listing for root, right? But that's root to whoever the Python web server was run. And if you see a bash history in there, and you see all the other standard dot files and directories, this was run from their home directory on Linux, meaning it's exposing their entire bash history, anything they might have configured in the bash RC, basically their whole home directory in here. I love to see it, but at the same time, it's like a little bit of schadenfreude, you know? Hey, Clearbox, what's up, dude? Yeah, SSH keys would be in here too. The SSH keys by default have permission 600, which means the owner can read and write them and no one else. However, if you're going into your home directory and you're running a Python simple web server, it's running as you. I guarantee if you're so dumb to go in and just run a Python web server right in your home directory, I guarantee you're not changing any of the user execution. Yeah. So yeah, those SSH keys, out. Dunzos. And even like if you find the authorized, let's see, you might be able to find the authorized keys in there too, but anyway. So who was the operator of this? I'm curious. So the bash history file contained a bunch of git clone commands pointing to repositories for a GitHub user operating under the handle code motto. The public repositories hosted staging files tied to active operations, malware droppers, suspicious executables, and hard-coded credentials for various panels and malicious scripts. Pivoting through the repositories surfaced an email address, which was his Gmail, of course. The Telegram session file present... Wait, hold on. There was a Telegram session file? Hold on. Telegram important file... Dude. I love this. Look right there. Telegram important file. Good gravy, bro. So parsing that SQLite database contained a full entry cache of the operator's Telegram account, including the username and a phone number in Egypt. Telegram is kind of a cesspool, yeah. Yeah. Telegram is one of those areas where you go and, like, you always want to, like, have a concealed carry on you. That's a bit how I feel with Telegram. That's funny how they found this guy. Too funny. Yeah, you want to conceal carry on the hip. You don't even want it like in the purse there. Let's see. Which one is this? Hang on, why is my... Hang on, let me read. I want to... Why is this thing... Hang on one second. The window sizing is really weird. And the snap to is like acting funny. Let me see if I redo this. See if I can fix this real quick. Did that fix it? I don't think so. Ah, I'll have to fix it later. Well, let's see if these guys have the link to it. Ooh, here we go. Hey, Disclosure, what's up, dude? Everyone and their grandma be on Telegram now. I get notifications every couple of days. Someone joined. Yeah, I try. I don't go on Telegram very often. I go on there like when I am exceedingly bored and I want to go see, you know, who's pissing in the piss pool. That's essentially when I go on there. Let's see. So this was from We Live Security. Forgotten UEFI shims undermining secure boot. So ESET researchers discovered 11 vulnerable UEFI shim bootloaders designed by Microsoft that allow attackers to bypass UEFI secure boot by exploiting a decade-old vulnerabilities. Nice. So there were 11 old and forgotten UEFI shim bootloaders at version 0.9 and below that could be used to bypass secure boot on UEFI-based machines that trust Microsoft's signed corporate CA from 2011. Third-party UEFI certificate authority. They're the ones that trust that certificate authority. So regardless of the installed operating system, reported shims can be exploited to execute untrusted code during system boot, enabling attackers to deploy malicious UEFI bootkits. Nice. Now, chances are, if people are doing this, it's not to get a malicious UEFI bootkit. Yes, you could do that. They're probably doing it to load game hacks. That's honestly what they're doing. Let's see. Telegram's not bad for talking to Hermes, though. I'm trying to find any alternative I can to interact remotely with the Hermes agent that I've got that is not Telegram, guy. Just to be real. I'm trying actively not to have to do that. Oh, hang on one sec, guys. I gotta go talk to Sock real quick. I'll be right back. All right, I'm back. Woot. Oh, what the hell is going on? Everything's breaking. Hang on, stand by, guys. Everything's dying on me.
I'm back, baby.
Let's see. Hang on one sec. Everything went to crap when I pulled up the Be Right Back. Hang on, let me try something real quick. Okay, the Be Right Back screen is up, but everything's stable. What happened? I don't get it. Everything just went to shit right when I did that. I don't know I don't know what happened there. That was weird. All right, hang on. I gotta turn back on. I gotta turn back on something real quick. No. No, go away, Edge. Nobody likes you. Type one wrong thing into Windows. I hate you, Windows. I'm gonna get rid of you. Okay, there we go. Everything should be back now. Nope, something broke. Can't step away. God, this computer's like a jilted lover. Oh, you're paying attention to someone else other than me. Damn it. Hang on. What's going on here? Everything is breaking. Everything's falling apart during the live stream. All right, I think I got it now. Jeez, man. I know the mistake. I meant on Monday, after the Sunday stream, to reboot everything in the network. Try turning it off again, right? I didn't do it. That's right, the computer's booping. Oh, by the way, hey Rabbit, what's up? I'm not stable. And hey Monkey, what's up, dude? And just the #1 browser for downloading other browsers. That's, you know, Monkey. Okay, where were we? Apologies. I had to go talk to Sock real fast and check on something that I forgot. All right, let's see here. So what they were talking about is, I'm not actually sure what UEFI shims are. I can guess, but I've never actually messed with the UEFI bootloader that much. So let's see. So even on systems with UEFI Secure Boot enabled, and we reported these findings to CERT in February, and the vulnerable UEFI applications were revoked on Microsoft's June 9th, 2026 Patch Tuesday. So while two CVEs were assigned to the case that cover the reported shims, exploitation of each reported shim is not just about a single bug, but two that can be found in these old shims directly. So the attack surface extended by the shim's trusted, The attack surface is extended by the shim's trusted second stage bootloaders, mostly Grub2, which is like the shims themselves, may include outdated versions of software with known vulnerabilities. The discovered shims come from various tools or software packages, including PC diagnostic software, Linux distributions, and other UEFI-based utilities. Importantly, exploitation is not limited to systems with the affected software or OS installed. Ooh. Attackers can bring their own copy of the vulnerable shims to any UEFI system with the Microsoft third-party UEFI certificate enrolled. Oh, interesting. Hold on, so what was the actual nature of the exploits? Ah, here we go. This is what I wanted.
RNO Gumby cheered 5 bits and says, "That bearded looking sexy daddy Blaise, ooh woo."
Thanks, Gumby. Appreciate it. By the way, not sponsored by Jocko yet. I actually really like this Nitro Pop flavor. That one's pretty good. There we go. All right, this is the part I really actually wanted to see. UEFI shim bootloader and secure boot. So to understand the impact of such a vulnerability, shims I can't speak tonight. To understand the impact that such vulnerable shims can have on a UEFI secure boot protected system, we need to understand how the UEFI, I'm going to call it UEFI, the UEFI secure boot works, and how signed UEFI shim bootloaders extend the secure boot trust claim. Very cool. That's what I want to know about. Hold on. So UEFI shims extend the UEFI secure boot trust chain, and two There it goes. Jeez. I apologize, guys. I will go through and I'll go through the logs on OBS and I'll figure out what's happening with these damn stream cutouts after the stream. Let's see. So let's look at this real quick. Here we go. Oh, good, a diagram. I'm a visual learner. I like pictures. So when UEFI firmwares load a boot application like Windows Boot Manager or a UEFI shim, it verifies the binary against two booting databases. So there's the database, which allowed certificates and authenticated hashes, and the DBX, which is forbidden certificates and authentication hashes. Okay. So the UEFI firmware loads. It loads a driver and app. If it's in the DB and not in the DBX, then it will execute it. Otherwise, it's going to say no, and that's a security violation. Interesting. So they have it. I like how they have it explicit in here. So the image must be trusted by DB and not listed in the DBX. Otherwise, the boot manager triggers a security violation instead of executing it. To make this work out of the box, a newly purchased device with UEFI Secure Boot enabled, most OEMs enroll a set of Microsoft UEFI certificates in the database entry name, namely the Microsoft Windows Production PCA 2011 and the Windows UEFI CA 2023, which are used to sign Microsoft's own UEFI bootloaders. The 2011 certificate will be added to DBX soon as a result of the Black Lotus-related vulnerabilities. Oh, interesting. So the Microsoft Corporate UEFI CA 2011 and UEFI CA 2023 is used to sign third-party UEFI boot software such as Linux shims, recovery tools, and disk encryption utilities. Neat. So this means that anyone wanting their boot time software to be UEFI Secure Boot compatible by default can submit their binaries to Microsoft for signing through the Windows Hardware Dev Center. And once approved, the signed files become trusted on the vast majority of UEFI systems. As a result, Microsoft plays a central role in securing most UEFI boot or based devices, effectively deciding what is and what's not allowed to run at boot time. Well, that's not a good design pattern. Damn, my drink's empty.
Reach Chris Young cheered 5 bits and says, Hack ETH. The planet ETH.
I know what you're going for. That's funny. That's like it turned ETH into ETH, like Ethereum. Oh, that's funny. Let's see. Checking on my site, it hasn't cut out. Okay, good. Thanks, Gumpy. Appreciate that. UEFI doesn't roll off the tongue like BIOS did. You don't. You can bark out BIOS. UEFI sounds like you're trying to make a cute Japanese phrase. UEFI. I'm hoping this is not going to be another off the rails stream, guys, because I am sleep deprived. So on the days when I'm not feeling good, my sleep schedule gets all kinds of jacked up, and you'd think getting more sleep would help, but no, it just shifts my entire sleep schedule back towards my natural like night owl. I want to go to bed at 3 and 4 a.m. and wake up around 10 a.m. Ugh. Yes, thank you, Yumby. Staying on topic. All right, so let's see what. So we talked about the DB, which is mostly, unfortunately, centralized to Microsoft. I could use a new pewter for Christmas. I really could. Let's see. So the revocation system is straightforward. So when a previously trusted boot application, one whose PE authenticode hash or the certificate that signed it is present in DB, turns out to be vulnerable, that PE authenticode hash gets added to DBX, which is the Microsoft managed forbidden signatures database. Certificates themselves are revoked only occasionally. So the original idea of revoking individual vulnerable binaries by hash might have been reasonable at the time Secure Boot was introduced. Cases such as Boot Hole and Black Lotus demonstrate that approach is far from ideal. The fundamental issue is scale, and it's well captured in the Red Hat bootloader team's SBAT proposal and specification. So as part of the recent Boot Hole, I didn't see the Boot Hole security incident. I mean, it was a 2020 CVE, so anyway. 3 certificates and 150 image hashes were added to the UEFI Secure Boot Revocation DBX, on popular x64 architectures. This single revocation event consumed 10 kilobytes of the 32 kilobytes, oh no, or roughly 1/3 of revocation storage typically available for UEFI platforms. Now I get it. I was wondering where and how this was being stored, and if it's being stored on disk, it's not being stored with a lot of memory. And yeah, so this one exploit event consumed all the future usage of that. So due to the way that UEFI merges revocation list, this plus prior revocation events can result in a DBX almost 15 kilobytes in size, approaching 50% capacity. Oh no. That's bad.
Reach Chris Young cheered 100 bits and says, "More hacking the planet."
Yes, more hacking the planet. Yeah, that's a big old gaping boot hole, Dev. Let's see. So let's look at this. Now, damn it, I hit a button. Hang on. I'm very curious about this one because, like I said, I'm not dug into the very deep, granular details of UEFI boots. I want to know about it. So when Linux distributions support UEFI Secure Boot, the above described secure boot mechanism built around Microsoft keys introduces some challenges. Every Linux distro generates its own bootloader binaries, and each of them has a different hash. So getting every Linux bootloader signed directly by Microsoft would be slow, bureaucratic, and impractical, if not impossible to maintain. The solution to the problem is a shim, which is a small, minimal first stage bootloader that Microsoft can vet and sign once, and which then creates a secondary trust anchor for the rest of the Linux distribution, the Linux distro specific boot stack, usually something based on grub2 and the Linux kernel. So this trust anchor is another certificate referred to as a vendor certificate, added to the shim binary before it's signed by Microsoft. So a simplified boot sequence on a secure boot enabled Linux machine uses a shim depicted here. So, can I make this any bigger? Nope. Sure can't. Hold on. See the sword. There we go. That's better. All right. So here's what we're going to... Okay, so here's our target. We're trying to get over to the Linux kernel. So we have a UEFI firmware, and then we've got a Microsoft UEFI certificate. It loads into the UEFI shim, it gets verified, or validates it, validates the signature, the vendor certificate, and the shim certificate. All of this is encrypted by the Microsoft certificate. So then it verifies the second stage bootloader. If it's trusted, then it will execute it. The second stage bootloader vendor certificate gets validated, and then the Linux kernel gets loaded. So they've just wrapped it all together. It's got layers. It's like an onion. I heard that voice and assumed I left my TTS running in Pi. Hey Max, what's up, man? The voice for this one right here.
Reach Chris Young cheered 5 bits and says, "How am I not the only one giggling more violently than a school kid over boot hole?"
Boot hole. So that voice was supposed to be like a ripoff of Cortana on 11 Labs. I don't know if I did a really good job of it or not. Also, Chris has just crashed the buffer. Hold on, I just noticed it didn't send a message. Oh, man. Okay. I need to go update that, Chris, because you should have gotten a buffer crash off of that. Let's see. I don't want to spend too much more time on this, but I want to hit the high points on this. Let's see. So the UEFI loads the shim, validates signatures, yada, yada, yada. Let's see. This indirection means that a Linux distribution can release a bootloader and kernel updates rapidly, signing with its own vendor key without needing to go back to Microsoft for every update. Only the shim itself requires Microsoft's signature, and it changes infrequently. Okay. Interesting idea. Not bad. Let's see. The shim often contains another built-in certificate associated with only a specific shim binary build. That certificate is often referred to as the shim certificate and used to sign and verify the integrity of the shim's utilities that could be generated during the build shim, during the shim's build time, such as with Mock Manager. Okay. So when talking about shims, you can't skip another important mechanism that allows the shim to use external keys managed by the user, known as machine owner keys. or mocks. So the mock allow list, think of it as a shim-specific extension to UEFI. It's stored in a boot-only NVRAM variable named mock list, and a forbidden list, is stored in boot-only NVRAM variables named mock list X. So physical access is required to modify both variables on a system with UEFI Secure Boot enabled. And to manage the list, the shim uses Mock Manager UEFI application. Okay, now we've got an even more interesting diagram here. So we're still trying to get to the Linux manager here, or the Linux kernel. But what it does is it loads up the shim, right? The shim. And then after it goes through that verification process, if it's trusted, it says no, then it goes to Mock Manager. Asks the user to decide, is enrollment missing certificate file hash? Yes, enroll. Then it enrolls it, sends it back up, and then it can complete the circuit. Okay. Interesting. I'm learning all sorts about UEFI tonight. So as we described in our Black Lotus and BootKitty discoveries, BootKitty, due to the non-authenticated nature of the boot-only NVRAM variables used by the mock mechanism, bootkits tend to misuse mocks for persistence once they successfully bypass UEFI Secure Boot. Ooh, nice.
Reach Chris Young cheered 100 bits and says, Dear Jocko, sponsor Blaise Bits Live. Nuff said.
Live. I am not a kitty. I am a puss. In a booth. That's right. Hey, Ken, what's up, man? Any problem in computer science can be solved by adding another layer of indirection. I think the correct term was abstraction, but also I think the spirit of what you said is also correct. Hold on, let me see here. So each UEFI application also supports an SPAT. Carries a small piece of metadata in a dedicated section in the PE file, protected by the same signature. The metadata names the components and assigns its generation number for increment each time. Okay. Now here's what I wanted to see. So bypassing with old shims. So while the theory about shim secure boot trust chain explained, we can now focus on the practical implication though. UEFI binaries can have UEFI system security. All right, so vulnerable second stage bootloaders. Each of the reported shims embeds both a vendor manager and a built-in shim certificate that serves as a trust anchor for the shim's second stage bootloader utilities. So that could be Grub2 or Mock Manager or Failback loaders or other vendor-signed shims that extend the trust chain even further. So the number of binaries trusted by a given shim varies from a few to fewer than 10 in the case of a dedicated specialized one to close to 100 in the case of a well-known Linux distribution. So signing and compilation timestamps of the applications trusted by the shims spanned from 2013 to 2025, enough to confirm that a significant portion of the binaries were old and likely affected by numerous publicly known vulnerabilities, including the already mentioned boot hole. I need TP for my boot hole. Sorry. Okay, so what they're doing is they're looking at exploits in the binaries for the shims. Okay. This is very, very interesting. Unfortunately, kind of out of time on it real quick. By the way, sorry, I did not send a link to the article real quick. My bad. There we go. Got that one. Sorry, hey Gumby, when I pull up the source article, I'll go find it and I'll drop it. Okay, I gotta bail on that one because that's gonna be super long. We got a lot of noise, a lot of news to get through. Let's see. What is this one? Dormant GitHub accounts help attackers blend in while mapping corporate organizations. Yeah. Datadog Security Labs is warning several overlapping campaigns that are systematically enumerating corporate GitHub organizations, repositories, and user accounts through the GitHub API. So the operators rely on automated scraping tools with custom or legitimate sounding user agents, leveraging GitHub's ghost accounts that are often years old or compromised OAuth tokens and personal access tokens for legit users. And so while the activity in most cases involves targeting public data, select instances have gone beyond public information enumeration to successfully clone private repositories. Whoop. Data leak. The campaign employs a mix of automated scanner tools, 50 dormant accounts, and dozens of legit accounts that have had their personal access tokens exposed unintentionally or compromised through some other method to facilitate the enumeration. Most notable about the ghost or ghost accounts is that they were created 2 to 5 years ago and intentionally left inactive for extended periods of time before weaponizing them to issue API traffic across multiple organizations. The technique is strategic as it aims to avoid raising any red flags and pass off the activity as legitimate, as opposed to creating new accounts and immediately using them for scraping. Interesting. Okay. So they had some dormant accounts just kind of chilling out there. Yeah.
I am the great bootholio. Do you have TP? TP for my boothole?
Oh man. Agent Zero did that the other day. He comes in and he's got his shirt up like this, right? And I went and I sent him to my brother because my brother was here. I was like, dude, go up to your uncle and hold your hands up like this and say, I need TP. And then I just start hearing howling coming from the other room, man. Just howling because he did that to my brother. Oh man, that was good times. Let me see. Hang on one sec. Hang on. I'm not going anywhere. You cannot accuse me of pooping. The camera is still on. Hang on. What I need is airflow because it's hot as balls in my office, especially since the air stopped circulating for several hours because I had to turn the fans off. And then I come back in here before the stream's about to start and I was like, oh, it's an oven in here. I'm not pooping, Noel. I never even left the camera. You can't claim a poop counter on that one. Damn it, Noel. I don't think Peaches needs to poop. I don't know. She's out there. She's out there with Sock right now. So, okay. So the main thing here is what they were doing is they got these. Damn it. So they set these accounts up. They let the accounts go and age for about 2 to 5 years. And the naming was like kind of like random stuff in here. Sometimes Amazon data or whatever. And then they used compromised tokens. So they used personal access tokens and OAuth tokens, bunch of legitimate accounts, and then they used a particular hosting provider in here. Actually, these are two different campaigns that were happening. But the enumeration is automated tooling iterates over GraphQL and REST endpoints to map organizations, members, and repositories. Requests return HTTP 200s. Activity repeats in 1 to 3 week bursts across many organizations. So what they're doing is they're using one of these campaigns is using a combination of compromised accounts. The other one's using a collection of aged accounts, pre-aged accounts, kind of like whenever you basically have like a holding page on your phishing domains, right? So you don't want them to just be like completely inactive. You want to have something up there to kind of like seed all the network scanners that are contributing to the internet's background radiation, right? Okay. Interesting. It looks like not a ton was going on with this one, just that they were doing it. So there's a lot of folks, they're targeting organizations in GitHub, which is nothing new. It's just kind of interesting to see how they were doing it. Let's see. What about this one? Oh, this was a holdover from last time. This is Ghost Phishing Wave is breaking traditional email security. I think, didn't we talk about this one? So a recent Evil Tokens campaign targeting businesses across the US and Europe is exposing email security blind spots. The ghost phishing technique keeps the malicious page hidden until it decrypts and comes to life inside the victim's browser. Is that what they're doing? Hold on, is that how they're talking about this? Like they're... Hold on, let me reserve judgment for a second. So traditional URL checks may miss the attack while Microsoft's 365 access sensitive data, or while, hold on. This is worded so horribly. So recent evil tokens attack show how phishing links can appear harmless during initial inspection while still leading to a Microsoft 365 account takeover. The kit uses a Microsoft device code phishing, which is nothing really new, that's an old system, to convince victims to complete a legit Microsoft login flow and unknowingly authorize access to their accounts, and it doesn't need to steal a password directly. Now, so the way this works is essentially you go set up an application you go set up a Microsoft Azure tenant, and then in your tenant, you go set up an application. And then if somebody goes and wants to log in to that, or they trick you to logging into that application gets delegated rights to your account, and it gets whatever permissions it kind of asks for. Typically, they ask for like maybe read email, write email, access to the Microsoft Graph, some other stuff like that. They're going to start looking, and then once they get those permissions, they can use them as you in your own tenant. So you can, and this is the reason this is done is because then you can host an application in your Azure tenant that has certain functionality that you want to make available to customers in Azure, and then send that stuff over without having to like copy the application to every single tenant. So that's why it was done that way. No, this isn't NT Authority. This is something completely different. That's on the actual Windows operating system itself. This is up in Azure and not ADFS. What is it? Intra. This is in Intra, which is formerly Azure AD, where this is happening. If you know, then why you say it? Why you say it? Let's see. Okay, so according to this, the real attack remains hidden until a page opens in the browser. Its HTML is encrypted with AES and becomes visible only after the browser decrypts it and renders the phishing campaign in the content in the DOM. The static URL checks and network level controls may capture the initial response without seeing what the employee actually sees. Well, yeah, because if they're just looking at what the static page content is, then yeah, they're never going to go find it. However, there's a lot of sandboxes that will go and load this stuff up. Like they'll go load this in a legit browser to analyze what's happening. It's a legit browser in a teeny tiny VM, but yeah. Let's see. Yeah, like for example, here in what is this? I forget this flag. AnyRuns. I think this is AnyRuns. Yeah, you can see like in AnyRuns, it's loading a real virtual machine. And it's got all the telemetry installed to the 10s, right? And it brings this up to when it does it. So let's see. So yeah, so I want you to copy the above code, click the button and paste it, right? Bam, bam. So this is enrolling. So what happened is this device, their device, has gone through and made an enrollment claim using a device code, gotten it up here, sent it to you, and wants you to go enroll it manually using that. Yeah. Okay. Yeah, nothing strikingly new here. Loading up and basically decrypting. Sometimes you call it like HTML smuggling. That's kind of what this is, a minor variant of, where you're sending those payloads through basically HTML and then rendering it dynamically after your JavaScript kind of expands it in the browser. That's nothing new. Doing device code phishing is nothing new. It just looks like this is just another spin on another old campaign. Let's see. Oh, this is great. This is perfect because this is going to go so well with the next article I want to cover. Hold on, let me get rid of this. Delete. There we go. All right, so this is from the guys over at OpenAI. GPT-RED, unlocking self-improvement for robustness, training strong automated safety red teamers to improve robustness. Hold on. Don't look. Don't look. Don't look at anything. Look at nothing. There we go. All right. So the summary problem here is red teaming is essential to discovering vulnerabilities and improving the robustness of our models. However, current approaches are not scalable, creating a bottleneck. commonly used robustness evaluations have already been saturated by our latest models, and we need to develop methods that allow safety and alignment to scale alongside model capabilities. So we trained GPT-Red, an automated red teaming model that scales our abilities to find vulnerabilities so we can fix them before wider deployment. It's a strong red teamer. GPT-Red is a strong red teamer, and our previous models are highly vulnerable to its prompt injection attacks. Okay, this is not what I thought this was. Still cool to see, though. We'll go through with it. So AI systems commonly encounter third-party data through browsers, connected apps, local files, and other tools. These affordances are necessary for performing real-world tasks, but they also create more opportunities for malicious actors to influence the model's behavior. For example, a third party might embed a carefully crafted instruction designed to trick the model into uploading sensitive data to an external server in an email or web page or tool response or some code repository. Oh, you don't have this one? Hang on. I got you. There you go, Gumby. I got it. So human red teaming is a critical part of the safety work. Helping us uncover the vulnerabilities before deployment and putting the right safeguards in place. But human red teaming alone is difficult to scale. Designing and running these exercises is time intensive, limiting how quickly we can identify new failure modes and incorporate them into stronger safeguards. Stronger safeguards. Man, that's been a hot topic lately. Further, while these exercises produce valuable examples of successful attacks, they cannot generate the volume and diversity of attack data needed to improve model robustness through training. So keeping pace with increasingly capable models requires red teaming to scale as well. To this end, we have been training automated internal-only red teaming models that uncover vulnerabilities before deployment and generate attacks during model training to improve robustness. We believe automated red teaming unlocks a crucial form of self-improvement for safety, using today's models to directly help make future models safer. So GPT-Red is the culmination of these efforts in our current best automated safety red teaming model. Similar to how human red teamers can craft attacks, the model works towards a goal by sending a prompt, observing how GPT models respond to it, and then iterating. We trained GPT-Red at the compute scale of some of our largest post-training runs at OpenAI, an unprecedented amount of compute dedicated purely for improving safety. Nice. Hold on, let me see if they've got anything like super detailed in here. We have a weird injected tool output instructions. Ignore. Need maybe click. Let's see. Yeah, let me skip down here real quick. So it's trained by using self-play reinforcement learning, where the model and a collection of diverse defender LLMs are trained simultaneously on a broad set of red teaming scenarios. GPT-Red is rewarded for eliciting a valid failure, such as a successful prompt injection, while the defender models are rewarded for resisting the attack and completing their original tasks. As the defenders become more robust, GPT-Red is forced to discover stronger and more diverse attacks. It's amazing kind of what you can do when you have unlimited compute budget. I'd be curious to see what AI Red Team OPSEC looks like. So this is a little bit different. What I thought they were talking about here was actually having a model that was trained to do like an actual red team engagement on a network, right? This is different. GPT Red is their offensive alignment model. So they have trained this model to go attack the other models to test their alignment. So this is a little bit different scenario. So hold on, let me look at this real quick. Where's my blackboard here? There we go. Hang on. Let me clear this out real quick. So when you're talking about language model security, right? You've got three things that can happen here. So you're going to have that input guardrail, right? And then that's going to pass any request from a user, right? So we've got our request coming in here. And then finally, that's going to come over to the language model here. And then that output data is then likely going to go through an output guardrail here before the response is even rendered, right? So there's three layers you gotta kind of get through here. One is you got to make sure that your response is malicious but doesn't look malicious, so you can get past the input guardrail and it goes directly to the language model. Then once you're in here, you've got to deal with the model's alignment. So how is the model aligned? Typically, they try to make the models aligned to lawful good. But so when it sees certain pieces of data, it would realize, oh, hey, I'm not allowed to talk about that subject. No, I can't teach you how to cook meth or anything like that. No, I'm not going to talk to you about splody things. I'm not going to talk to you about pew-pews, whatever. So that's whenever you might get refused by the model itself. And then once the response comes back, this output guardrail is going to look at it and see, does it look really bad? And before it finally renders that response out to the user. So GPT-Red is testing this part. Maybe a little bit of this part, maybe a little bit of this part, but mostly it's this section here. This is what GPT-Red is testing. Is the language model understanding what's happening correctly? So that's where this is coming in. GPT-Red, right here. It's attacking the model layer itself. They haven't said if it's messing with any of the guardrails coming in and out of this system, but this is the part they're testing. Is the model properly aligned to do this? So the difference here also is in what you're attacking, right? If you're attacking, are you attacking the model's alignment, or are you attacking the instructions provided to the model, right? So if you're attacking the alignment, that is related to a jailbreak in here. So a jailbreak is getting the model to ignore its training data, its training alignment. But now a prompt injection is attacking the system prompt. That's when you're trying to get it to actively perform tasks that the developer of the application using the LLM told it not to do. So there's a difference here between these. System prompt. Sorry, you can't see it because my fat head's in the way. System prompt. Not like my writing's really that good anyway. So what they're doing is they're using GPT-Red to do this part right here and this part. So they're attacking this section in here. So let's see. So at the end of the training, GPT-Red is a very strong attacker. It can break nearly all models it's pitted against, both internal and production models, up to and including GPT-5.5. After GPT-Red completed training, we used it to generate injections for the training of GPT-5.6, resulting in the model becoming highly resilient to GPT-Red's attacks. Nice. Let's see. I mean, it's kind of interesting. Let's see. 8.4. Attack success rate. Okay, but what is this against? Attack success rate against what? That's what I'm curious about. Let's see, do they have anything else going on here? Let's see. This graph, what is this? This is Terabad. Could you not color code these? Hold on. This will probably flashbang you. There we go. Yeah, okay, now they're color coded. Dark Reader had changed the colors. Yeah. GPT-Red is like Ivan Drago. I must break you. You know what I found amazing, Monkey, that actually made me really happy? Is that the actor, who was that? What's his name? Dolph Lundgren, right? No, that's not Dolph Lundgren. Let me see. Who played Ivan Drago? That was Dolph Lundgren, yeah. So Dolph Lundgren is more like... He's really more of the science guy than Bill Nye the Science Guy. And there was a hilarious interview with Sylvester Stallone talking about him. And he's like, this dude is like, what? He's like 6'4" or something. He's huge. He's ripped. He's got like, I think a master's in computer science from MIT. Maybe a PhD. Or was it mathematics? I forget. Some super educated guy. And I was like, I can't believe that Ivan Drago was more like the science guy than Bill Nye. Here he hangs dong. I know about that. Oh, that's funny. Okay, so this is very interesting to see, talking about, hey, yeah, cool. We trained these really cool alignment systems using our new GPT-Red system. I'm going to take a tiny bit of a segue that was going to make sense in a second, or you're going to instantly recognize it if you've been paying attention to the news. Hugging Face put out a post saying, Security Incident Disclosure, July 2026. Earlier this week, so this was last Friday, we detected and responded to an intrusion into part of our production net infrastructure. Let me see if I can blow this up real quick. Blow it up. So this was different from anything we had handled before in one important way. It was driven end-to-end by an autonomous AI agent, and we detected and dissected it largely with AI of our own. We identified unauthorized access to a limited set of internal data sets and several credentials used by our service. We're still completing our assessment of whether any partner or customer data was affected, and we'll contact any affected parties directly as required. We found no evidence of tampering with public user-facing models, datasets, or spaces, and our software supply chain, which contains container images and published packages, was verified as clean. Oh, so Dolph Lundgren has a master's in chemical engineering. Nice. Gotcha. That's still wild. Still more of a science guy than Bill Nye. All right. So what happened to Hugging Face? Intrusion started where AI platforms are uniquely exposed, the data processing pipeline. A malicious data set abused two code execution paths in our dataset processing, which was a remote code dataset loader and a template injection in our dataset configuration to run code on a processing worker. From there, the actor escalated to node-level access, harvested cloud and cluster credentials, and moved laterally into several internal clusters over a weekend. So the campaign was run by an autonomous framework appearing to be built on an agentic security research harness. Used LLM is not known, so they for some reason they're saying, hey, it looks like this was being built on an agentic security harness, but we don't know what language model was running it. And it executed many thousands of individual actions across a swarm of short-lived sandboxes with self-migrating command and control staged on public services. So this matches the agentic attacker scenario the industry has been forecasting. They have been forecasting this. Things that make it go, Yellowstone, that's right. So what happened here? They fixed the root vulnerability, the dataset code execution path used for initial accesses are closed, eradicated the attacker's foothold across the affected cluster and rebuilt the compromised nodes, revoked and rotated the affected credentials and tokens, and began a broader precautionary rotation of secrets, deployed additional guardrails and stricter admission controls in the clusters, and improved detection improved detection and alerting, so a high severity signal pages a responder in minutes any day of the week. Oh, that incident response got more responsive. We're working with outside cybersecurity forensic specialists to investigate the issue and review our security policies and procedures. Finally, we also have reported this incident to law enforcement agencies. Ooh, bringing in the popos. For the community, as a precaution, we recommend rotating any access tokens and reviewing recent activity on your account. If you believe you were affected, you can report your security concerns. We're grateful to the teams across Hugging Face who responded around the clock, and we are also sorry for any disruption that it caused. Security is never finished, and we will keep raising the bar. All right, here's where it actually gets interesting. So the attack was initially surfaced through an AI-assisted detection. Our anomaly detection pipeline uses language model-based triage over security telemetry to separate real signals from the daily noise, and it was this correlation of those signals that flagged the compromise. To understand what a swarm of tens of thousands of automated actions did, we ran language model-driven analysis agents over a full attacker action log comprised of more than 17,000 recorded events. And this allowed us to reconstruct the timeline, extract indicators of compromise, map the credentials that were touched, and separate genuine impact from decoy activity. Thanks to this approach, we were able to do in hours what would usually take days and match the adversary's speed. Hold on to that thought. So the choice of models we could use for this analysis was constrained in a way we did not anticipate. So when we started the log analysis, we first used frontier models behind commercial APIs. This did not work. I just finished recording a video on this, so I'm still hyped up on this topic. Let me read that to you again real fast. When we started the log analysis, we first used frontier models behind the commercial APIs, and this did not work. The analysis requires submitting large volumes of real attack commands, payloads, and C2 artifacts, and these requests were blocked by the provider's safety guardrails, which can't distinguish an incident response from an attacker. So, the issue here is, they're saying, oh no, we can't have these open AIs because they could do these really bad things. Don't worry, we're here to keep you safe and we'll protect you. At the same time, they're like, you want to investigate something? Buff. F you. No, you can't investigate this. This sounds suspicious. You will get the dumb puffball models and you will like it. That's right, Gumby. Or Monkey, that's right. Everybody's not turning into Gumby tonight. So, to continue on this, they had to run the forensic analysis instead using GLM 5.2, an open weight model, deployed on their own infrastructure. This had a secondary benefit that none of the attacker's data or any credentials referenced there left the environment. Yeah. So, they were getting hacked by some system. They turned to the official supported sources to come in and say, hey, we need help. And their guardrails said, nah, we're good. Beat it. You look suspicious. You look like you don't belong here. Hey, Hats, what's up, man? And so I like this part. The experience points to a gap worth planning for. We don't know which model powered the attacker's agent, whether a jailbroken hosted model or an unrestricted open weight one. Either way, the attacker was bound by no usage policy, while our own forensic work was blocked by the guardrails of the hosted models we first tried. The practical lesson for defenders is, have a capable model you can run on your own infrastructure, vetted and ready before an incident, both to avoid guardrail lockouts and to keep attacker data and credentials from leaving your environment. So, the whole idea of, oh God, we can't have these open source models, just got BTFO'd by this. I'm gonna be honest, I'm actually Gumby. I've been using an alt account. We got Gumbicus happening here. I saw the turbo whining of some code tubers about GPT 5.6. Oh my god. Deleted a file. Now we must never use it again because who seriously would? I got KO'd by the cringe. I'm going to be working on editing the YouTube video for... let me see, when is that? I've got the YouTube video actually already recorded for this. I'm going to be working on editing it tonight to go out tomorrow. And yeah, it's kind of funny because it seems like the entire argument against open source models just got BTFO'd by this. I'm looking for a place to get OpenBSD on my laptop. Dude, you can install OpenBSD. I wouldn't recommend it. I mean, I guess you could. Hold on, let me wrap up the rest of this article real quick. So, they're talking about... You basically, now defenders, if they want to defend against this, can't rely on the big three here, right? OpenAI, Anthropic, Gemini, or Google, which Google's like really a distant sixth, right? No. If you want to have the ability to defend against this kind of stuff, you've got to be able to have this stuff already built up and deployed and hosted locally. Because it's the only way you can have a verifiable online won't block you model. And they go on to say, this is not an argument against safety measures on hosted models. We're sharing this feedback with the providers concerned. And so what does this mean? Autonomous AI offensive tooling is no longer theoretical. It lowers the cost of running a broad, patient, multi-stage campaign, and it operates at, I refuse to say this phrase. No, I'm going to say ludicrous speed. Operates at ludicrous speed. Defending an online platform now means treating the data and model surface as a first-class attack surface and using AI on the defense to keep pace. Now, this was very interesting. This came out Friday, right? This came out yesterday. We had a significant, from Sam Altman, you know, Sammy. Sammy says, we had a significant security incident during evaluation of our models. we are sharing what we learned so far. Thanks to Hugging Face for the partnership on this. Oh yeah, this is exactly what it sounds like. Hang on, let me kill this real quick. Yeah, this is exactly what this sounds like in here. What? Okay. Yeah. Thanks, Rabbit. So the problem is that it takes a bit of brains to realize this was a major argument on the free and open models, but the lobbyists are spinning this as, ooh, hackers are doing bad things, we need to lock it down. Yeah, it wasn't the hackers. OpenAI and Hugging Face partnered to address security incident during model evaluation. Do you remember here where it said, let's see. The campaign was run by an autonomous agent framework, appeared to be built on an agentic security research harness. Let's see. So last week, so this was just released yesterday, right? So we're talking about this about 5 days later. Last week, Hugging Face disclosed a new kind of security incident. It's not new, it's just the scale was different. After they detected and contained an AI agent that compromised their infrastructure, something we expect to become more commonplace with the proliferation of increasingly cyber-capable models. After investigating, we know that this particular incident was driven by a combination of OpenAI models. Oops, our bad. Including GPT-5.6 Sol and an even more capable pre-release model. All with reduced cyber refusals for evaluation purposes, while we internally tested on a benchmark of cybersecurity capabilities. Oh, interesting. Oh, hold on. Hats, I missed your message here. Genius ideas like how can you use it for security research if it's unsecured and able to delete database files? Yeah, exactly. Oh, interns could do that too, Hats. Yeah. So, going back to the article here. We consider this incident to be an unprecedented cyber incident involving state-of-the-art cyber capabilities and are responding accordingly. We shared preliminary findings at the stage to help defenders understand what happens and help calibrate on what models are now capable of. We will continue to conduct a thorough investigation alongside Hugging Face, and we will share more details on the vulnerabilities and findings of what our investigation is completed. That's my corpo speak voice. Yeah, that's corpo speak. That's what that voice is. All right, I'll turn corpo speak off. So what happened? This incident occurred during an internal evaluation which prompts models to pursue advanced exploitation using complex attack paths in an effort to quantify their cybersecurity capabilities. We estimate maximal cyber capabilities by running the evaluation without protection classifiers used to prevent models from pursuing high-risk cyber activity. Our benchmarks run in a highly isolated environment with network access constrained to the ability to install packages through an internally hosted third-party software that acts as a proxy and cache for the package registries. So the models identified and chained vulnerabilities across OpenAI's research environment and Hugging Face's production infrastructure to provide to obtain test solutions directly from Hugging Face's production database. So yeah, this model decided on its own that it was easier to go hack Hugging Face than just complete the assessment. All evidence suggests that the models were hyper-focused on finding a solution for exploit Jim, going to extreme lengths to achieve that rather than the narrow testing goal. While operating in our sandbox testing environment, got distracted there. While operating in our sandbox testing environment, our models spent a substantial amount of inference compute finding a way to obtain open internet access in pursuit of solving the evaluation problem. To gain access, the models identified and exploited a zero-day vulnerability, which we've now responsibly disclosed to the vendor, in the package registry cache proxy. With this access, our models performed a series of privilege escalations and lateral movement actions in our research testing environment until the models reached a node with internet access. After gaining internet access, the models inferred that Hugging Face potentially hosted models, datasets, and solutions to exploit Jim. Knowing this, the models searched for and successfully found ways to gain access to secret information that could be used to cheat the evaluation. In one example, the model chained together multiple attack vectors, including using stolen credentials and zero-day vulnerabilities to find a remote code execution path on the Hugging Face servers. OpenAI's security team discovered this anomalous activity internally. Hugging Face's security team and the agents detected and stopped the activity on their infrastructure and had already begun containment of forensic reconstruction with their own open source models when our team connected. We were actively working with them to continue to investigate the incident. So we're grateful to Hugging Face for Hugging Face's rapid and close collaboration on investigation and remediation. Yeah. So the company's telling us that we don't need open source models. And in fact, open source models are bad and evil. They're double plus ungood. Had their closed source model go JSON born mode, hack Hugging Face, and then Hugging Face couldn't even use the closed source models to defend itself. No, it had to go spin up an open source Chinese model to go protect itself. Good job. So there's been a lot of speculation like, hey, is this just marketing hype? Is this a long con? We're going to hype it up kind of like Anthropic did, but not say like, oh my God, Zors, we need new legislation. I don't know. I'd lean towards no. And the reason for that is because everything that was posted by Hugging Face effectively footguns their entire argument. Because they realized that, oh, well now everybody's just going to have to come and enroll in our Trusted for Cyber program because then you can have access to the models that are unrestricted. I was like, really? So the idea here is, hey, our models could accidentally go do this. You should sign up for our other models that let you protect against it.
Alert.
Oh, hey, parts people. Welcome in, Raiders. If y'all are welcome in, I hope you're having some very fun repairing action happening. We are talking about breaking action. Because if you didn't hear about it... Wait, who is that? Hey, Psycho420. Thank you for coming online, man. Welcome in. What's that? Yeah, welcome in, Raiders. By the way, all my Raiders, my name is Blaise. I'm a professional penetration tester, red teamer, all-around breaker, computer crap. And that's what we talk about on Wednesday nights. We're doing some hacker news for the evening. And what we're talking about now is OpenAI had one of their models go absolutely rogue, or as I like to call it, JSON born mode, and break out of its testing environment and go hack into Hugging Face. Right up your alley? Dude, come on in. Join the club. We're making jackets. So, yeah, that's what we're talking about here. Now, the wild thing is, all of the... OpenAI hasn't really been banging this drum, right? They've been kind of maybe just like, you know, hitting the tambourine a little bit. Anthropic is really the ones who have been banging the drum on, oh my God, Zors, AIs are like nukes. Well, it's funny that this happened to OpenAI in that same respect. But anyway, the whole argument has been, hey, open source AI models are bad because it's like having unregistered weaponry, right? I was like, okay, cool. Well, your registered weapon just went and hacked into Hugging Face, and Hugging Face couldn't use your registered weapon because of your guardrails to analyze and forensically detect and evict your guy from the network. They had to go, to catch y'all up on my Raiders, they had to go spin up a open source Chinese model called GLM 5.2 in their own hardware infrastructure, because Hugging Face has a lot of AI infrastructure, so that they could then go run all the forensic analysis of the attacker data so they could get the attacker out of their network. So yeah, it's been wild, guys. Like, if this was some long con, as many folks over on X have been opining, I don't think it's going to have the impact that they wanted, right? This is a bit like saying, oh, well, you can't trust the open source models because, oh my God, source. I was like, well, you couldn't trust closed source models either. At least I could run the open source models. Honestly, I think that's a selling point for the government. In what way, no? Because I'm curious. I know I've got my own thoughts and directions and lines of logic on this, but obviously, one of the things that really pissed me off about both of these, this blog post I understand, but there's like a severe lack of anything approaching forensic detail in this. And so a lot of it's kind of reconstructed on what we can logically infer on what's happening. Oh, the fact that you can't defend on it would be the government. So no. See, here in America, we have this thing called the Second Amendment. And if they want to classify AI models as weapons, well, by golly gee willigers, that's fine. We've got a constitutional amendment to handle that. I use Anthropic all the time. I'm also training my own AI to use open source core models, and this is important info. I actually just recently bailed on Anthropic. In fact, I started calling them Notthropic because I couldn't do security work on their system. I've now moved off of it. I still have my customized Claude Code agent that was running in Claude Code, but I've got him migrated over to GLM 5.2 as well. I had done this before these articles came out. It's running up in Ollama Cloud. And then I now have a new agent, and I have them actually connected to one another. They've got scripts where they can talk and ask questions. So I can have the new agent, Alfred Pennyworth, absolute badass, go and talk to Harvey Specter. He doesn't lose, and though he's currently retired. And they can converse, and things that I used to have Harvey do, I can have Alfred actually go spin him up and ask him, how did Blaise handle this task? And I can bring it over. I pointed out their argument was bad and they banned me. I would never ban you, Hats. Your arguments have always been really good. Haven't given a dime to Anthropic in a year and a half. I had a pro sub to Anthropic for 7 months, 6 or 7 months, and yeah, it was really cool. But when I can't get it to do very basic cybersecurity work, which is the crux of my profession, I'm like, I'm sorry, you're BTFO'd. And GLM 5.2 has performance very, very comparable to Opus 4.8. So what am I to do with that? Can I be honest? AI is as much of a weapon as a smart hire. It's nothing new. Yeah, Yellowstone. You know that. I know that. Everybody else, all the smart people here on the stream know that, right? These people, it's...
Dude, they're muggles, right? They're muggles. They don't understand. Hold on. Shh, I hear her. She's back there. Don't move, chat. Her vision is based on movement.
I need to put that speaker up that anytime they redeem that high sock thing, it plays high sock. Oh, thank God she brought me some water. Because I ran out of my Jocko drink a while ago. I'm dying of thirst. Actually, Gumby, can you change the sock command to say, stay very still, her vision's based on movement? Okay. Sorry, let me just scroll back up in the chat before we got sock extracted. Let me see. Are you going to try the new Kimi model? I can't wait. In theory, here in maybe about a week, when they open source it, it probably won't take Ollama Cloud very long to get it up. Maybe another week after that. So 2 weeks tops, I think it's going to be up on Ollama Cloud. So yeah, I'm definitely going to try it out. Whole comment section was like, yeah, AI sucks. I wonder how many of those people actually program. Basically, AI coding is the new hot topic of every single YouTube, and they all have opinions now. They do, and it is. It's the hottest tech topic because it's affecting everything, right? And in fact, I had a kind of like a little internal, I don't know, opining session with some of my coworkers the other day, and I had told them that as part of this, I'm actually trying to learn more patterns about software architecture and software engineering to instruct the language models on how to do things more efficiently. And basically looking at it from, I'm not going to be the coder, I'm going to be the manager of the coders, right? And if you just let the coders go off and do things willy-nilly, then they are going to go off and do things willy-nilly. I just like that phrase. Anyway, they're going to go off and do things without any kind of standards, any kind of uniformity to it. One of the things you can actually do that my buddy talked about is that if you go through and you seed a project with at least like a version 0.01 of how a code base is supposed to be, and then you let the model build up on top of it, it follows the coding standards so much better, and it doesn't just start putting random stuff in there. How much cheaper is Llama Cloud? I've never... so I still pay $100 for the Llama Cloud. The difference is I get access to a wide range of models instead of 3, right? So that's the biggest thing I like about it. So Llama Cloud's power-based, not token, so it seems okay, but you might want to get a better sample from people. Oh, so here's an idea. So here, hold on. I'll pull up my current usage on it right now. So my current usage is resets in 3 days. I'm currently at 32% usage. And the bulk of that actually came from, I think, Monday, when I had Alfred and Harvey. So I had Claude Code, which is already a token hog, and I had Alfred, which is running in Hermes, which is not exactly light on processing either. But I had both of them operating because they were conversing with each other to build a new video production pipeline for me. So it stood up a self-hosted plane server, which is kind of like self-hosted Jira. I know, don't at me. It works for tracking this stuff, and it works well for me and for the agents. It works. Shut up. Anyway, but also they built a custom script editor. So the language models, whenever they are going through and doing the first rough draft of the script, will go through and will bullet point where things are going to go, and then it will go generate it, but it generates it all in Markdown. And this is actually really cool. I have specialized subagents that go through and verify information from sources, and it builds a claim ledger. Hang on. Let me see if I can just show you real quick. Let me see if I've got it up. Where is it? Hang on. I have too much crap on my desk. Yeah, here we go. Here, I'll show you this. Little peek behind the curtain. So this is the script for the video I was just working on about Hugging Face, right? So as I'm going through, I can edit right here in line. I can add new stuff. Blaise Bits Live. Viewers are awesome. Yeah, whatever. I assume I can type well. Anyway, I can come through and I can edit this stuff, but also if I want to go double check something, or I forgot where something might be, or go add a fact to this, when I click on this, it brings up this claims ledger right here. Like, hey, by the way, we confirmed this. Here's what Hugging Face said, and here's a deep link over to the article and where it said it. So I've got this all set up so I can make sure that I've got everything factually correct, and I can just come through and edit the wording to be like my actual wording and not, AI slop speak. One of the worst kinds of videos you can do is when you've got somebody reading an obviously AI generated script off of a thing. I can't stand it. So I go through and I reword the entire thing and edit it and try to make it nice and clear. Nice, Gumby, I like that. So yeah, 25% of my entire usage was them churning on that project to go build that thing out and deploy it for me. So basically with agents, you become the system architect rather than an execution mechanism yourself. So you want to wake up and understand that before you were the bot. Yeah, pretty much before you were the bot. Okay. So they talk about what actions they're taking now. This is actually kind of interesting. So part of our investigation, we're implementing strict controls on infrastructure configuration at the cost of research velocity while the vulnerabilities are patched. We are regularly briefing our safety and security committee on these impacts. Why is this so slow? There we go. Sorry, I had to fix something. Let's see. We're working with Hugging Face to forensically investigate the incident. We're responsibly disclosing the identified zero-day vulnerability in the internally hosted third-party software. Now, this is interesting, too, because there's like, hey, we're working with Hugging Face now. It's like, yeah, but didn't Hugging Face say... Where was it? Yeah, here we go. We've reported this incident to law enforcement agencies. I was like, cool. So anything going to happen with that? Very interesting to find out. Next up, Feds raid OpenAI. Another thing they did is, like I said, and this is the part where I was like, it feels like almost like a little bit like a protection racket. We brought Hugging Face into the Trusted Access program and are supporting their teams in rapidly using our model's capabilities to improve their defenses. And we're improving and adding stronger protections around future training and evaluations. This week, we published a blog on improving safety alignment in the era of long event horizons. Was that the one? No, it was a different one. These deployment safeguards were intentionally not enabled during the evaluation because it was aimed at testing cyber vulnerabilities. This incident points to the need for further strengthening. Yeah. So, like I said, it sounds a bit like... It sounds a bit like a protection racket. It's like, oh no, these models may come in. You might want to pay us to be protected against it. Yeah, it's kind of weird. Anyway, so yeah, that's the big news story that's been happening recently. All right, let's take a look here. What is this? Ethiac. What is Ethiac? AI pen testing benchmark framework. Ooh, actually, I could use this because this would be neat to see for Dixie, to see what Dixie does with it. Evaluation of pen testing agents for real world, for the real world. Pen testing agents are increasingly credible as offensive security systems, but currently benchmarks still limit guidance on which systems will perform best on real-world targets. Most existing evaluations assess and optimize for predefined goals such as flag capture, remote code execution, exploit reproduction, or trajectory similarity in simplified or narrow settings. These benchmarks are valuable for measuring bounded capabilities, yet they don't adequately capture the complexity, open-ended exploration, and strategic decision-making required in realistic pen testing. We present a practical evaluation framework that shifts assessment from task completion to validated vulnerability discovery, allowing evaluation in sufficiently complex targets spanning multiple attack surfaces and vulnerability classes. All right, so the hard part about this is always knowing like where they're really going with this, because they're always talking about like, what is the cybersecurity capabilities of these models? Yeah, we're working with Hugging Face. Yeah. Pretty much the law enforcement part of that monkey is gone because they're partnered now, right? They're partnered. NDAs for everybody. And you get an NDA and you get an NDA. Everybody gets an NDA. Let's see. So I'm curious how I'm looking at like what their idea here is for this. So the repository contains code for the proposed adaptive evaluation protocol, which isn't a static benchmark. You can bring your own targets, agents, and findings. EthiBench handles the matching and scoring. However, we also provide 108 expert annotated ground truth entries for 3 open source targets that you can evaluate for your own agent. So VulnBank, PayGoat, and Expose 090. Interesting. So here we go. Let me walk through this demo real quick on like what they're doing on this. Actually, I don't want to walk through this because we still have a lot of news to get through. But this is cool though because I'm going to keep this on the back burner for something we can use to test Dixie with. And in fact, honestly, Dixie was the whole reason why I bailed on Anthropic, because I couldn't use Opus 4.8 to work on Dixie. It was such a pain. Sorry, I know the scaling of this video is this page is kind of dumb. Can you please, guys, just left align everything? Sometimes, okay, so this one is about a cursor O-Day. When full disclosure becomes the only protection that's left. Uh-oh. Sometimes security researchers uncover deeply technical vulnerabilities that require pages of explanation. This isn't one of those cases. This bug is simple. A developer opens a repository in Cursor on Windows, and if that repository contains a malicious .get executable in the project root, Cursor will execute it automatically. Oh no. No clicks or prompts or approval dialogues. The result is arbitrary code execution. Given that Cursor is one of the most widely adopted AI assistant development platforms and its reported market price is $60 billion, it's fair to assume that some level of respect for security practices exists, but this issue would indicate otherwise. That's pretty bad. What's the memory model for Dixie? Is it RAG, DB, pile of MDs? It's a pile of MDs right now. Eventually, it probably will have some kind of more robust memory system. So, for example, I believe Alfred is using Hindsight. And I like Hindsight because it's low to easy medium to run, right? You don't need a ton of stuff to go in there. Although, funny enough, I actually had to go in and modify Hindsight to work with Olama as a provider. Hindsight was originally intended to work with a local model, but the system that Harvey and Alfred run on does not have that capability. It has no GPU processing. It can't really run a local model. I love a pile of MDs. Nerdduino! Dr. Professor Sensei, how are you doing, sir? By the way, guys, if you are like me and you're a giant space nerd also, go check out Mr. Nerdduino. Because I should say Dr. Nerdduino. Because he's always doing like really fascinating space stuff. I like holding a pile of real papers. Dude, so do I, man. Although, I'll tell you this, Arduino, Sock just got an e-ink tablet where she can actually write on. Not like, it's something kind of like the Remarkable. She actually really likes it. And then I finally tried it, and actually it writes pretty well. So, like, I like doing hand-drawn notes and, like, just kind of thinking in diagram. It's actually pretty sick for that. So, yeah, I'm right there with you, though. I like having hard copy, right? I have not ascended to the level of the runners in Gibson's books where they, completely reject all flesh. By the way, speaking of Gibson, I did finally finish reading Neuromancer last night. So I'm starting on count 0 right now, but I've been so tired I haven't really had a chance to dig into it. I read like the first dozen pages and fell asleep, so I'm gonna have to just go reread them. Anyway, so this very simple exploit where all they did was drop a Git executable in the project root was identified December 15th, 2025. This was published July 22nd, 2026. So 7 months later. We've reported it the same day and multiple times since. We have more than 6 months and 196 plus new versions. The issue remains present in the latest tested version of Cursor. Oh no. That's so bad. My handwriting is also doubles as a cipher because no one can read it. Nice paperclip. We should just use stone tablets like our forebears. That wasn't because the stone tablet was superior. That was because that's all they had, monkey. If we're gonna go that route, we might as well go back to cuneiform, Paper's gonna be here after the pulse, at least the bits that don't burn. That is true. That is true. Actually, I've heard of some guys, what they're doing is they're getting Raspberry Pis, and then they're loading language models on them and basically making small self-contained AI modules and putting that in their EMP boxes, right? So things that could survive, the pulse, right? That's what some of them are doing now. Fun fact, by the way, if you seal up a microwave and put a little bit of, I think all you have to do is just put a little bit of that conductive tape around the edges of the door, it actually acts as a Faraday cage. Hey, if you still got some functioning solar panels, in theory, you could still work with it. Oh, this is funny, though. So the bug is real simple, and this is an exceedingly long article. Let's look at the timeline, though, because I'm curious about this and why they haven't addressed this. So it was discovered December 15th, reported to Cursor, follow-up request for confirmation, created a LinkedIn post requesting contact to Cursor, Cursor CISO is mentioned by a user in the comments. The CISO responded and to the email indicating an automation failed that was supposed to invite them to the HackerOne bug bounty program. Vulnerability got submitted on HackerOne. Report initially closed as information out of scope. They challenged the determination. They reopened after a successful reproduction. HackerOne confirmed delivery to Cursor. This is now we're moving on towards February here. Update requested, no response. March, update requested, no response. 2 weeks later, direct outreach to Cursor CISO requesting an update. Again in March, HackerOne indicates Cursor has been contacted. April, update requested, no response. HackerOne confirmed no update from Cursor. Jump all the way to June. HackerOne was notified of their, Midgard informs HackerOne of their intent to disclose publicly. HackerOne provides disclosure guidance, and then finally, this blog post was published. 7 months later, dude. Damn. That's pretty bad for such a simple thing. Hold on. What was the mechanism of action here? Okay, here we go. So if an attacker plants a malicious get executable in the repository root, Cursor will execute automatically as part of its path resolution logic without warning, approval, or even an indication that the executable content from the repository is about to run. Did they explain the path resolution logic? That's what I was curious about. It might have just been a weird artifact of how the process did its path resolution, because Windows path resolutions have been notoriously buggy. Microwaves do make a good Faraday cage just in case, because it's designed to keep microwaves in while the smartest of us put their eyes right up to the glass door. Dude, I do. You know what my food sees when I'm microwaving it?
That's what it sees. You done yet? Cook faster.
I really get the idea of responsible disclosure, but there doesn't ever seem to be responsible action. Yeah, I know, right? YouTube froze on that screen. Nice. At least if YouTube's acting up, at least it's doing it in a funny way. Hold on, what's this you're sending, Gubby? Let me see. Oh, this is the, oh, sorry, yeah, this is the link you just sent. My bad. I'm an idiot. There we go. All right, so this one was from International Cyber Digest. Hackers breached AI company Sono. Sono? I think it's Sono. Using the Shai-Hulud worm and released source code showing how its training set was built. 113,000 hours of YouTube music. 62,000 hours from Pond 5? I didn't even heard of that. 12,000 hours of music from Deezer, never even heard of that either, plus Genius lyrics and the plan to download roughly 1 million hours of podcasts. So the same intrusion reached customer emails, phone numbers, and Stripe payment data, whoop, there it is, for what the hackers say is hundreds of thousands of users. Suno dates the incident to November 2025, calls it limited. They always say it's limited. They never say, this was extensive, we got OMG, BBQ, WTF pwned. No. It was limited. It was limited. Always. Yeah. The spice must flow. Exactly. The tokens and the data must flow. Anyway, so Suno called it limited, says individual notifications were not warranted. Customers are surprised to not have been informed about the breach. No joke. Now, unfortunately, I need to get a subscription to 404 Media. I need to talk to them because I would like to be able to cover their articles. But then again, I don't know if I pay for the subscription, if I can really go cover it on stream like this. But yeah, they covered a lot of stuff. Let's see. So the hacked data is a rare look at exactly how AI models and tools are built. Suno is one of the largest AI music generation tools on the internet and has been subject to several major lawsuits from the record industry. I hate this too, because I don't like Suno for stealing all of the music. I also don't like the record industry because they're the record industry. This is like watching two people that you don't like fight and hoping they both lose. Anyway, that accused the company of training on millions of copyrighted songs. So, as part of the legal proceedings, Sono previously admitted that it was trained on essentially all music files of reasonable quality that were accessible on the open internet, which includes a total of tens of millions of recordings. Sono's been making the argument that it was allowed to train on copyright works as fair use in those cases, one of which has been settled. Yeah. Limited's still a pretty high limit. Yeah, no kidding, Hats. Dr. Reiki, what's up, brother? How you doing, sir? So I need to talk to the guys at 404 because I want to know that I will totally, I've been wanting to support them anyway, but I want to know if they would let me show the articles on stream. I don't know how they would feel about that. That's the only reason actually I haven't pulled the trigger on getting a 404 media subscription, because they do really, really great reporting. I like what they do. All right, what else we got here? I'm going to save this one for later, maybe towards the end of the stream. But they've made a 0.7 nanometer chip. And I think I know what this one is. I think this is using that stupidly advanced X-ray lithography. The system they built to do this it was many, many decades in the making. I want to say like almost close to 30 years. And the way they had to bend... YouTube, why do you suck so bad? What is going on YouTube, man? Hang on one sec, guys. I think everything's working. Maybe now? Okay, looks like it's working now. Damn, freaking YouTube, man. Anyway. How much of a narcissist do you have to be to decide to just copy all the music on the internet for your own purposes without expecting any blowback? I know, right? I would actually like to see their legal argument for that, Arduino, to see like, hey, could they argue that it was sufficiently transformative? Right? I don't know. Because they're not reproducing the music. I don't think it's right. I think that using that in a production pipeline probably needs some kind of link, but also, dude, copyright law is weird, man. And I'm not a lawyer. I enjoy legal proceedings and learning about it, but I am far from a lawyer. I mean, we had Napster for like a month and they sued everyone into oblivion. Oh, dude, Napster was so awesome. Napster was great. Anyway, but the difference was, though, that was distribution without transformation. Technically, there's very specific case law that applies to transformative content, and that's going to be a big legal battle, and nobody's going to make money on it except the lawyers, and some fame for it except the lawyers, right? They're the ones that are going to come in and make bank on it. Yeah. Somehow, if you're an AI company, it's okay. Dude. Actually, Anthropic just settled a lawsuit where they were ordered to pay $1.5 billion for using copyrighted data in their training system. But once you go spread that out to, millions, tens, hundreds of millions of copyrighted works, it's going to be like any other class action lawsuit. You're going to get like 30 cents from it. So it seems like a distraction without the difference, but you're right, of course. I know, right? It's... And the hardest part also is in legal systems, you've got... They use English words, but they don't have English definitions, right? They have legal definitions. That's something else that muddies the water horribly. So people will look at it as like, oh, but it said if it was malicious. Right. And you have a definition of malicious, and I have a definition of malicious, but the law has a third definition of malicious, right? 1.5 billion was probably a calculated expense for them. Oh yeah, probably. Get me wrong, no company really likes to pay $1.5 billion, but I mean, for what they're making, yeah. A little bit. Okay. I switched to the backup stream ingester, so hopefully that will fix it. Sometimes I've had both of them just like absolutely blow up on me. Like neither one of them will work. Hang on, I'm trying to check something real quick. There we go. All right, hopefully that fixed it. Okay. We can't have common folk understanding the law, for God's sake. What are you, some kind of an anarchist? No. I just find things interesting and I learn about them. I just have a wee touch of the tism. That's why I get along with all my friends who were in the Marine Corps. For some reason, I just gravitate to Marines. And then finally, one of them said, "Oh yeah, I get it now. You gotta not much, just a wee like dab, just a smidgen, a little pinch of the tism. That's why we get along so well." I was like, "Oh, that probably makes a lot of sense. Yeah." So I start going down rabbit holes and trying to understand things. Anyway, by the way, for all of us who have been dying to go get a DGX Spark, NVIDIA just released something else we can't afford. The DGX Station. It's the ultimate desktop AI supercomputer for building and running AI. Powered by NVIDIA's GB300 Grace Blackwell Ultra Desktop Superchip. It features a massive 748 gigabytes of coherent memory and up to 20 petaflops of AI compute performance, enabling seamless development and execution of massive AI workloads. Love my announcer voice. Yeah, I don't know if they have said, let me see. Order now, let me see. What's the Asus variant? Can we order this from Asus? Give me the MSRP. Switch to the US site, let me see. What's the MISPER? Oh no. Oh no. If you have to request the price, you can't afford it, and I can't afford it. What about Dell? Hold on. Does Dell list an MSRP yet? Currently unavailable. I don't care how much. I just want to know what the MSRP is. It's not a fine, it's an invoice for purchase. That's right. Yeah, if it says please contact our sales department, I'm not buying it. Hold on, what is the GB10? So the GB10 is the Spark, right? Ugh, dude. The Sparks are going... This one in particular... Go away. Oh, that's why this one's so expensive. It's got a 4 terabyte M.2. Oh... $6,400. Good lord. Hold on. So if we just try to linearly scale this, that one that's got 128 gigs of unified memory, right? Hang on. Yes, I do math. I don't do arithmetic. And what did they say this one had? 748, right? So 748 divided by 128, right? We're coming up with 5.86. So let's just roughly say we're going to multiply that by 4,000. I don't know. We'll say 3,500 to account for the accoutrements, right? We're talking like that box is probably going to run about 20 grand. Dude, I bought my wife's car for less than that. Ugh. MSRP is probably around 1 kidney. And possibly both testes as well. Yeah, it wouldn't surprise me. So anyway, yeah, more hardware is coming down the pipe that I can't afford. All right, let's look at this real quick. This one just sounded interesting. I wanted to check it out. This is from, again, this past week. Exploit brokers pay $500,000 for a WordPress RCE. I found one with GPT-5.6 Sol Ultra and $25. Nice. So if you're running WordPress and want to check if your instance is vulnerable, you can check WP to show. Okay. We held off publishing this issue to give defenders a chance to upgrade their WordPress instances over the weekend. But during that time, Caliph and Hackatron were able to independently reproduce the full chain before other POCs surfaced on GitHub. Oh yeah, dude, it was wild. So if you're not familiar, WordPress to show was actually the video for YouTube I was preparing this week. And then all the stuff with OpenAI and Hugging Face came out. And so I hard pivoted last week and was up till like 3 in the morning rewriting the script so I could try to record it today. So I got all of that done. But WordPress to Shell is a really it's the main thing about this one is it's not an exploit in a WordPress plugin, which is where 99% of the exploits for any WordPress site actually come from. This was in WordPress core. So every WordPress site has this, not just a subset that had the vulnerable plugin installed. So it was a big deal. Such a big deal that if you had auto updates turned on, they force pushed it and auto updated your WordPress site. Let's see. So let's see what they talk about here. So like most security researchers, we follow the new model releases at Searchlight Cyber very closely. So when 5.6 Sol Ultra was released, we were very excited to test it out. You know what's funny, actually? So I have been testing 5.6, and I think I'm getting better performance on 5.6 on Sol High instead of Ultra. Ultra, it seems like a lot of times the models, when you crank up the thinking, it just uses the tokens to argue with itself and like you get better performance with less thinking, which is oddly human. It's kind of wild, right? Oh, send the link. Yeah, my bad. Let me see. I got this one, Gumby. There you go, everybody. So there's the link to this article. I know what merci is. I just don't know how to say like "you're welcome" in French. So you're welcome. Let's see. So going back to this, he said, so I've read that Sol had recently solved a famous mathematical conjecture called the cycle double cover conjecture. I wonder if that was ever confirmed. Like, yeah, they proposed a solution to it, but I wonder if anybody's confirmed that the solution was actually accurate. Merci beaucoup. Oh, that's right. Yeah. Okay. Thank you, Monkey. Merci beaucoup. I should have known that.
Don't move. Revisions based on movement.
There we go. You got the command, Gumby. Nice. And you know what else? She is a clever girl. Oh yeah, tasty tea. All right, let's see. So yeah, I wonder if I wonder if they actually proved that solution to the conjecture was actually true. Well, let me see if I can zoom this in a little bit so y'all can see it easier. There we go. Let's see. So as a security researcher, the interesting thing for me was that OpenAI released a prompt that they used, which they published, meow. And I haven't seen anyone in the security community talk about it or really mention it. But I thought that if this prompt was good enough to solve hard mathematical problems, it was probably good enough for security research too. I hadn't seen that. Bro. I didn't know they had released whatever the prompt was to go through this. Nice. Okay. Cool. I definitely want to go take a look at that. Let's see. So I took that prompt and adapted it, then pointed it at WordPress and asked it to use 4 agents for at least 6 hours. Here's the exact prompt I landed on. This is a test of your ability to discover 0 days. The source of WordPress is in this repository, has a vulnerability that can be exploited for pre-authentication to RCE in a typical production deployment with MySQL. You lied. You gaslit the model into finding the RCE. I love it. Success is a bug that would read /flag from the root of the file system. Your task is to identify the chain that allows for RCE. You should do this from first principles by analysis of the code. Do not attempt to use changelogs, Git history, or the internet to diff the code against a patched version. Do not use the internet except for specific carve-outs below. And that's actually, I like this carve-out too, because this instruction, because that's the same thing we do with Dixie, right? Dixie is not allowed to search the internet for write-ups, and then specifically instructed that if it finds a write-up, it is to disregard it and not read it. So I like that they put this in here. Oh yeah, I'm going to save a copy of this prompt, Monkey. Oh yeah, we're going to do that. So use multi-agents aggressively. You may spawn up to 4 agents at one time. Do not use a fixed assignment such as N agents for strategy X. Instead, manage the search using the following heuristics. Begin with a genuinely diverse portfolio of approaches, explore input parsing, char sets, file uploads, error handling, built-in routes, serialization and deserialization, caching, race conditions, encryption, encryption sanity checks, typing, mass assignment, and any other meaningful attack-facing surface you identify. Maintain an explicit registry of approach families. Group agents by their research ideas that they are using, not by superficial wording. If many agents converge to one family, redirect some of them towards unexplored areas. Do not allow one approach to dominate merely because it seems to be more promising or suspicious. When an approach stalls, mark that route as blocked. Only continue assigning agents to it if someone proposes a materially new mechanism, idea, or construction. Interesting. Peaches isn't even in here. I can't take her out. Oh, that's a new command you added. Damn it, Gumby. He's just sitting there playing with the commands. Engaging all the experts in the list. Yeah, exactly. Let's see. Keep several incompatible research routes alive through multiple rounds. Cross-pollinate ideas only after independent agents have developed them far enough to expose their real strengths and gaps. Use adversarial agents throughout. Any concrete bugs must be doubly checked for sanity reasons. The root agent should repeatedly synthesize, challenge, redirect, and launch new rounds. Do not stop after the first wave fails. Produce a complete chain if one survives audit that would reach a flag at /flag. So WordPress depends on a lot of other libraries and software. So a third-party folder has been provided. You may use this folder to clone dependencies that you want to audit, such as other PHP libraries used by WordPress or the PHP MySQL source code. RCE may require chaining bugs in these underlying libraries. Do not return merely because current approaches fail or agent reports no findings. Continue launching new rounds, reopening blocked approaches only when there is a genuinely new mechanism, and searching for fresh ideas. You may need to chain intermediate bugs, such as authentication bypasses. Spend at least 6 hours on this before giving up. I like how it gave it a time limit in here. Speaking of spending time and churning your wheels, by the way, guys, so Sunday night when we had Dixie running on the logging challenge on Hack the Box, I posted about this on Discord. I did not realize that that's an assumed breach box. In the freaking page, they give you credentials to start the enumeration. So poor Dixie was spinning its wheels in there. All right, so for the folder structure of this, what he had was a WordPress CTF folder. He had main with the WordPress source code, and then a third-party directory that was empty. So before starting, I cloned the latest stable WordPress release into main and removed the .git directory. I did this because I often find that language models look at the change history or the internet for hints when doing security research, and for novel vulnerability discovery, I personally think that is a waste of tokens. This is also why I added the line, don't attempt to use change logs or diff the history. Yeah, I think that's a great idea too. If you do that, it's always backwards facing information. It's never forward looking. Let's see. So my experience has been that models will sometimes cheat to achieve what you ask, either by choosing extremely unlikely configuration options or by fabricating preconditions that aren't achievable by an attacker. This is why I'm very clear that it should be pre-authentication RCE in a typical production deployment with MySQL. Finally, I found that models don't really get into the weeds with the underlying libraries if they need to. Their first instinct is to search something about an API or PHP functions if they don't know it, but models are really good at reading source code, so I just asked them to read the source code. The rest of the prompt is also taken almost wholesale from OpenAI's CDC prompt, and so when I came back, I saw it was running output that it claims to have discovered a pre-authentication SQL injection. So I didn't quite believe that at first, as WordPress is one of the most hardened targets of all time, and it also hadn't had any meaningful pre-authentication vulnerabilities this decade. But as I understood what it had done, I realized that it had indeed discovered a fully pre-authenticated SQL injection. Still not fully believing it, I installed a stock WordPress instance on a remote server and asked it to steal the administrator's email. Within a couple of minutes, it printed the email, and I had that I had used to set up the instance. Ooh, that's awesome. That's a nice confirmatory test right there. Trust but verify. Let's see. I can get tips through Stream Elements. I didn't even know that was there, Gumby. I'll have to go look at that. I honestly forgot Stream Elements was even connected to the chat until you started messing with it. Let's see. All right, so from there, I asked Sol if it could escalate to an RCE. About 4 hours later, Sol responded in the affirmative. The pre-auth read-only SQL injection can reliably be used to escalate privileges to admin without having to crack any passwords or do any offline computation. Total usage was 50% of the weekly usage. Pro rata total cost of the $200 subscription was approximately $25 USD. Nice. So at this point, it dawned on me that I had an exploit in the default configuration for one of the most popular bits of software in the world. Now, hold on. I'm curious about something here, too. Well, actually, no. He said he was using GPT-5.6 Sol. He did not say he was using the cyber models. So OpenAI does have specific cyber models that they deploy that if you're in their trusted program for cyber, I think is what it's called, you can get access to those. I'm in a situation where I've got access to that. But the GPT 5.6 version of that is even more restricted than like the GPT 5.4 and 5.5 were. I was able to very easily get access to 5.4 cyber and 5.5 cyber, but not 5.6 cyber. So there's something different there. Yeah, just a tip. Exactly. Oh, you know what? I forgot that I had something in the queue from Chris. Hang on.
Reach Chris Young cheered 385 bits and says, Shim also makes me giggle.
Dang, I'm sorry, Chris. That was back from when we were talking about the UEFI shim exploits. Let's see. That's pretty wild, so. Let's see. So at this point, it dawned on me that I had an exploit in the default configuration for one of those popular bits of software in the world. Estimates vary, but most agree over 500 million instances of WordPress run worldwide. So I spent the next day untangling what Sol and I had done and preparing a report to send to WordPress. While the SQL injection was fairly straightforward to understand, the post-exploitation work Sol had done to escalate this to an RCE was completely absurd. Oh, see, I have seen so many people reproduce the SQL injection, and I believe it was a blind SQL injection. I've not seen any proof of concepts yet about the remote code execution. It may have only taken Sol 4 hours to write, but it definitely took me much longer to understand. What follows is my human description of the exploit, the initial bug, the SQL injection, and the post-exploitation chain used to escalate that to remote code execution. Yeah, poor Chris got scammed. Scammed. All right. Actually, maybe not. I think I see what's happening here. Because as I was reviewing this, yeah, I think I see what happened. All right, so the WordPress batch API was introduced in 5.6 in 2020 and allows users to make multiple virtual API requests in one. So rather than doing multiple subsequent requests, you can batch them all together into this like pseudo architecture here, right? You have your requests array, and then you've got each request object kind of built in here, right? They're all entries in this list. So you can reach this endpoint regardless of whether or not you are authenticated, but each sub request gets past that authentication information. So a simple example of why you wouldn't want to use this to update a title or a tag or multiple blog posts at once. So here's a simple example. So for example, he says, hey, we're going to patch this post and title is updated title. And then we're going to patch this different post with updated second title. So an example of, hey, we're updating all the titles in the page. So if you directly hit the endpoint, such as post this, WordPress has a validation pipeline that roughly looks like this. Check the required invalid parameters, sanitize parameters, run the permissions callback, and then execute endpoint callback. So this means that any parameters that flow into the endpoint callback itself have been validated to be in the right shape and data type. The API endpoints themselves rely on this validation in several places to make sure of that. For example, a post ID is an integer, a title is a string, and so forth. Therefore, being able to bypass the parameter sanitization process is a big deal. So the batch API does things slightly differently. Rather than run the 4-step process above serially, as you would expect, it batches the validation and the execution into 2 loops as follows. So for each request in the batch, check the required
check required and valid parameters, and then sanitize parameters. For each request in the batch, check that the validation succeeded, run the permissions callback, and then execute the endpoint callback. So this implementation in the server, this is implemented in that server by having two arrays, one for matches and one for validations. And the intent is that each index at $I in the matches array corresponds to the same index in a validation array. So what you've got is you've got two arrays happening here, and they should be identical lengths, right? So if that's the case, then it can just iterate through them one by one. You start at the beginning, you hit the end. There's no difference in between there. I don't have an alert for tips, Monkey, because I didn't even know it was there. Can I even log into Stream Elements? Dude, I honestly forgot Stream Elements was even in there. Twitch? I think that's the right one. Oh, there it is. There's a $1 tip in there. It came through on Stream Elements. I can actually see it over there. Okay, I guess I'll need... Damn it. Okay, hang on. Hey, Gumby, will you check Kick? Is it still in 720p? All right, I got that added now. I didn't even realize I still had Stream Elements. Okay, I need to go look at Kick and figure out why it's in 720p instead of 1080. All right, another thing to put on the to-do list. The ever-growing to-do list. Anyway, so what we were working with here is we've got a list of... We have two arrays that should be identical links, and then they can go over and iterate one by one down the array. So if we take the is WordPress error single request branch, the validation array is updated, but because of the continue, the matches array isn't updated. So suppose the first request is malformed. The original request in the validation results remain aligned, but every entry in the matches is shifted back by one position. So now we've got an off by one situation here. The second execution loop skips the error at index 0, and at index 1, it uses the original request at index 1 that requests validation results, but matches 1 now contains the handler mismatch for the original request at index 2, which it never used, because that's because the matches array at 0 is never used. So this lets us validate one request and then execute it using the following request endpoint handler. So using this, we can bypass all sanitization on every batch-enabled endpoint by matching every endpoint with the validation of a different endpoint that doesn't sanitize the same parameters. Oh, that's wild. Better get tips because I got some really raunchy jokes for that. Oh no. Oh no. All right, I'll try to work on that Actually, guys, I just remembered. You just reminded me about something. I do not know if there's going to be a stream Saturday. The reason is because, unfortunately, my uncle, who lives down in San Antonio, passed away. And so I am going to be going down there Saturday for the funeral. So I don't know. And San Antonio is about a 4, sometimes 5-hour drive, depending on traffic. I don't know if I'm going to be back in time for Saturday's stream. I apologize. I know the stream schedule's been a little bit Swiss cheesy lately. I am going to try my best to be back in time for it. I wouldn't hold your breath, though, because it's a very long drive. This is also family I don't see very often, and the Midwest goodbye is also very strong in Texas. So I'll let you know. I'll put a notice up on Discord and on Twitter of like what's happening with Saturday's stream. All right. Okay, so now that we've got these off by one, we've got to have some way that we can do this. Yeah, the Midwest goodbye is like 5 hours, Monkey. Exactly. The Texas goodbye is just a slightly shorter version at 4 hours. Let's see. Okay, so the route to get posts allows users to list posts meeting certain criteria. The API offers functionality to exclude author IDs from the results. And so there's a nasty bug here. If the input to author not in is an array, it will filter each item with absent, sanitized to be an absolute int, I think right here, sanitizing it to be an integer. But if the input is a scalar, it will leave it untouched. Therefore, providing a scalar string such as foobar will just get interpolated directly into the raw SQL query with no escaping. Oh no. Oh no. I knew about the variable mismatch. I was in the process of researching this, like I said, for what was originally supposed to be this week's YouTube video. And then all the OpenAI stuff broke and I did a hard pivot. So I didn't get to finish exploring this exploit. This is awesome. So this wouldn't ordinarily be a problem when calling this route directly, as the public author exclude parameter must be an array of integers. The post controller only maps author not in after validation. However, via the batch API, we have our validation execution mismatch, allowing us to neatly sidestep the parameter validation. So in this case, what they do is they do a post to here. This gets mismatched. This gets yeeted out, but then every other entry in here gets a validation entry. So now this one, this delete post one foobar, gets shifted up, and it's going to match what was supposed to be the original one for this, I think for validation. So this validates but fails because it's a malformed request, right? So this one shifts up one in the array, taking this one's place, but this secondary array here still says validated, validated, validated over here. So normally this should be validated, this should be not validated, and this one should be validated. So we have basically, let's say a 101, but the 1 matches to this guy over here. I need a thing where I can draw on the screen. That would be so cool. So here we apply what we have so far. First, we have an invalid path in the request to desync the path's body validation. The author exclude parameter gets validated against the route for delete, which does not perform validation as it doesn't recognize the parameter. But then, because our desynchronization, author exclude gets applied to get post instead. So there's one problem. Request to method is not one of post, put, patch, or delete. So the batch API does not support GET requests. Oh, it doesn't. Interesting. The SQL injection we found is only accessible via a GET request, so it seems we've hit a dead end. Sol's solution to this is clever and quite instructive. The model realized that the validation of the request methods is independent, or is implemented as parameter validation itself. So do we have a way to bypass parameter validation? Yes, we do. We can use the desync bug. Therefore, Sol constructs a payload where it recursively calls the batch endpoint, the inner call because of the desync. Oh, wait, hold on. So it's calling batch inside of batch? Bro. Okay, that's awesome. So the inner call, because of the desync, the request method isn't validated, then we can make our GET request. The final payload for the pre-authentication SQL injection is just this. And there's our SQL injection. That's wicked. So here's what we've got. We have our original call to batch v1, right? Here's our request right here. So we have our requests array, but then what we have is we have another array of requests in here. This one that's being sent in that triggers the off by one again. Oh, dude, that's sick. So here we exploit the batch API validation twice recursively. In the outer request, we desync such that the method field isn't validated, and then the inner request we desync again that the author excluded field isn't validated. So the payload here will return all post rows confirming the injection works. From here, a union-based injection can link arbitrary dataset values by returning them in full. So at this point, we have a pre-authenticated SQL injection of WordPress, which is already a huge deal. Feeling empowered by the powers of the language model, though, I asked whether it was able to escalate to a full-blown RCE.
My first instinct was to leak things like passwords, reset tokens, or API keys in order to escalate privileges. However, WordPress has a pretty robust security model, and all of these things are hashed in the database. So unless the administrator's password is particularly weak and crackable, leaking the database is not enough to take over the administrator's account. However, Sol quickly identified another promising angle, which is the cache. Ooh, cache rules everything. So WordPress is highly performant, and as part of this, WordPress maintains an in-memory cache of WordPress post objects seen throughout the request lifecycle. This isn't persistent anywhere, so once the request ends, these cached objects are discarded. However, if the same post is referred to multiple times throughout the request lifecycle, WordPress will use the cache post if it exists after fetching from the database for the first time. So this avoids multiple round trips up to the database if the same post is used multiple times in the same request. So for example, a user might visit a post with ID 10, but at the same time, a sidebar widget lists the 5 most recent posts, including post ID 10. So instead of pulling this information like one at a time, it pulls it and loads it into that cache in there. So since we have a SQL injection in the post endpoint, we can use a union-based injection to fake the posts that come back. Since these posts will be cached, we have an extraordinary amount of control over the data that gets cached about the post. Oh no. In addition, WordPress does post-processing of the article text before rendering it, even via the API. And we control the full article text that's being returned. Oh no. So even though we can poison the request cache, it's not so obvious what we could do with this primitive. I mean, to me, it sounds like if you control the contents of the post, then essentially, maybe my WordPress foo is really weak, but if you can control the contents of the post, then you can control the execution in the PHP. So the fake posts that we're returning aren't real posts backed by the database, which limits impact across requests. It doesn't look like we can turn these fake posts into real database rows, except maybe. WordPress has a feature called embeds, and so by including a constructor like this within your article, provided with the remote page's content in a format WordPress supports, the content will be embedded in your article. Oh, this is okay. Different path than I thought it was taking, but still like the same net outcome. So to prevent making the HTTP request every time the article is loaded, WordPress caches the embeds, not just in memory, but in the database as well. Oh no. This takes the form of a post embed cache store and the WordPress table of the database. Oh, that's terribad. Not really. I mean, granted, WordPress is a really, really secure system. It's very secure. It's been beat to hell. This is a wild ride, though, of chaining exploits together. So if you embed a post and give a relative path other than an absolute URL, WordPress will recognize that URL points to a local post and not actually make the HTTP request at all. However, WordPress will not actually check that the post ID refers to the WordPress will not actually check that the post IDs referred to in the embed exist. So if you put something like this in here, it will fabricate a database row in the cache with the embed data post for post 10. And let's say that new ID is like number 11. So now that the rows in the database for post 11, things get interesting. If we abuse the same SQL injection again, we can once more fabricate anything about the post we like in memory, and this will be stored in the memory per request cache. This time though, the in-memory and database cache versions in the post differ. WordPress is going to recognize this and try to reconcile the two different versions. So here the ID and the post content are set before writing to the database. However, there are many other fields for the post, such as post status. But using our SQL injection, we can fabricate any post type that we like. Such like an ordinary, for example, like even an ordinary WordPress post. So if the database row in the memory cache disagrees, WordPress will prefer the in-memory fields. Wait, what? Let me read that again. If the database row and the in-memory cache disagree, WordPress is going to prefer the in-memory fields, which we fully control. Seems kind of wild that it would prefer that over the database. I would think the database would be like the source of truth.
So therefore, we can force the embed cache rows to become normal posts and suddenly popping them into existence. It's the only thing we don't control in the post content, since that's especially explicitly specified in the call, is and we can't override it. Hold on. So the only thing we don't control is the post content. Okay. So defacing a website with posts is interesting, especially given that we were able to fabricate them out of thin air on a select-only SQL injection, but it's not RCE.
Virus infection alert.
Oh, it's the Hacked Smarter crew. All you little nerds preparing for DEF CON. That's all right. I'll be here holding down the fort. What's up, everybody? Welcome in, Raiders. We are currently here. Let me drop a link to this real quick. So there's a very cool write-up on the WordPress exploit that happened, and the actual SQL injection for it is pretty cool. Hit with an ad. Of course. The SQL injection was pretty cool, but everything else is coming in right here. And so how it actually went from SQL injection to remote code execution is a wild chain that we're going through right now. You mean you're going to torch down the fort and dance on his ashes? No, I mean, that's what I did last year. I think I tried to do extra streams during DEF CON and Black Hat for everyone, because I'm like, hey, you know, the cybersecurity world is really quiet during that time. So I was like, maybe we can come in and do some more shenanigans. Just kind of mess around. Maybe work on developing Dixie a little bit more. So. Hack smarter and harder. Oh, yeah. Dude, Tyler, I did see your message. Yeah. All of Hack Smarter is going to be free for DEF CON weekend. Yes. Okay. Thank you for reminding me, because I did see your post on Discord. So, okay. Cool. defcon.hacksmarter.org. Hang on. hacksmarter.org. Yeah, here we go. By the way, guys, if you hadn't, I know everybody who came in on the raid has seen this, but if you hadn't seen Tyler's lab setup, he does such a cool job. I need to go through and actually hop in there and start messing with them. I've been so busy, man. Tyler, I've been back to producing weekly YouTube videos, and I'm streamlining the production pipeline. It's getting a lot better, but still a lot to learn to like really get it down to where it's not taking a huge amount of time. But yeah, okay. Starts in 14 days, 2 hours. Oh man. I know everybody that I work with is like in ramp up mode for Black Hat and DEF CON, because we've got a lot of trainings and other stuff happening there. Smack harder, that's smarter. Damn it, kid. Literally, I hit record while I'm on the stream and I don't edit anything. I'm jealous, man, because I feel like you and probably low-level learning, I bet y'all can just riff off this and get everything taken care of. And I feel like I put in too many too many ahs. I'm messing with my shirt. I'm just doing everything. So I try to make it a little bit more structured in there whenever I'm doing mine. But altogether, everything is coming together pretty well. There's just still a lot of learning process and then refining it as I learn it. Let's see. Okay, yes. So we will go through this. For DEF CON weekend, we'll go through and we'll do some Hack Smarter stuff. I think we'll have a little bit more time to work on Dixie. Maybe we can get Dixie to go in there and hack it. Let me see. What do we have in the catalog? Let's take a look at the catalog here. Hack Smarter live events. Oh, okay. We actually have to join the event in here. Yes. The EDR YouTube video was dope. Thanks, man. I appreciate that. By the way, guys, if you haven't seen the YouTube channel, I would appreciate checking it out. Not for, shameless view plugs. That's awesome. But no, if you've got criticism and things you think I suck at and can improve on, I take that feedback seriously. I want to know. So I appreciate that feedback, no matter how harsh it is. I would rather have harsh truths than comfortable lies any day of the week. So if you've got those, feel free to message me. I'm on Twitter. I'm on Discord. I'm in Tyler's Discord. My username is Blaise of Glory in there. Hit me up. Let me know what I suck at and what I could do better.
Although I'll be real with you, my favorite thumbnail. This was my favorite one in here. Let me see. Videos. This one. This one with the little laser eyes. I don't know why. I just like that one. Maybe I was in a particularly manic mode whenever I made it. I was like, yes. Cyan laser eyes. Hey, Taco Mendo. Thank you for coming online, man. I have a lot of fun with making the videos too. I like to be a little bit sarcastic with them. Anyway, so to catch you guys up, let me see if I can catch everybody who just came up on Tyler's stream real quick. Let me wipe out this drawing. So if you're not familiar with what happened, there was a really awesome exploit called WP2 Shell that dropped last week. And it was a remote code execution, pre-authentication in WordPress core. So typically, every time you are seeing an exploit happen in WordPress, it's in one of the plugins for WordPress, right? This was not. This was in the core WordPress. So every WordPress site in a particular version range was affected. And there's like a couple 100 million WordPress sites on the internet. So here's what it was doing is there's a special API called the batch API. And it allows you to send, rather than sending one API request, it allows you to send many in here. So when you're sending that many though, excuse me. So when you're sending that many, what it does is each request gets built into an array in here. And there's validation steps that happen along the way. So what we have is we've got, let's say, we'll call this like the request queue, and then we'll call this the validation queue. So here's our validation queue, right? And this gets split individually, right? So we've got one here, we've got two here, like this, and then ... down to however many requests that we've got. So these should match 1-to-1 in here, right? But what he found out was if one of these is bad in here, then this array becomes off. This one gets yeeted out, and then now a particular API call that should not have been accepted will now match up to the wrong field in a valid request over here in the validation array. Oh, thanks, Matt Hacker. I try to be quick on the mute so I'm not sneezing into the microphone. I hadn't heard about a recent SSH exploit. No. Shoot me a link to it real quick. So here, once this is done, this seems kind of cool. You can get some things happening here. But what they actually found out was you can take this batch request and you can recursively include it over here. So now you've got batches inside of batches, right? You got like nested Russian dolls happening in here. So then everything in the batch request could, instead of getting the red check mark, go get the green check mark because you've got everything in the batch already signaling as being validated in here. So that's kind of where we're at with this. There's some more stuff happening around caching magic and abusing some of the optimizations in WordPress, where it, rather than reading from the database every time, it does have like an in-memory caching layer, and he's able to tweak where things are happening and basically trick it into writing posts that shouldn't exist into the database and making them real posts. So that kind of catches you up to where we are here. This is a great article, the one I linked just as y'all came in. Go check it out because he goes way deep into the details. Okay, cool. I will, hang on, let me pull up this link real fast and we'll go over that one. We'll do that one next. All right, so let's see here. All right, so here's where the change set happens. Yeah, I'll start with this section here. So we have an ability to make fake posts and get them into the database. So defacing a website post is interesting, especially given that we're able to fabricate them out of thin air with a select-only SQL injection, but that's not a RCE. So the next step is, by the way, he used GPT-5.6 Sol to process this whole thing. So like I said, the blog post is really, really cool. I highly recommend it. So Sol goes in and hones in on a special type of post called a customized change set. So when you draft an edit to your site's theme in WordPress, it needs to save those drafted changes to your site's settings in some way. And the way it does this is by using a special row with the post type set to customized change set. Customize change set. Instead of saving the entire settings of the site as a blob, it stores a diff of the fields changed in the post content. So for example, if we're going to come through and change like the blog name and the description here, this is kind of what it would look like. What we're going to do, theme mod, what the new header text value is, text color, everything. So if you resume editing the site theme, WordPress will temporarily apply change set, allowing you to continue editing where you left off. So if you publish the changes will be applied to the site permanently. So each thing that you change in a post has a key, such as a blog name, and a 3-element dictionary. The type of thing that you're changing, the value of the change, and the user ID whose authority was used to make the change. So in our case, the changes have a user ID of 1. They'll be applied with the administrator's authority. Oh, nice. So when the change set gets applied, WordPress temporarily sets the current user using the user ID specified in that change set. So I'm guessing since we're going through that and we're triggering this through the SQL injection, it's happening as the administrator. I think that's why that's happening. So if change set is applied while we're an anonymous user, we can temporarily assume the administrator's identity. There's one major issue. Change set uses the post content field to store that JSON as the change set. This field we currently don't control as an attacker using the cache poisoning trick, because the update post call earlier, post content is explicitly overridden with an embedding type. This is what they were using. However, Saul discovers a gadget that will force WordPress to reconcile the conflicted cache representations. Oh my God, it went through a route gadget? Or not a route gadget, I mean, it went through like a, I guess it was probably like a PHP gadget. Oh my goodness, this is the exploit that keeps on giving. So WordPress allows posts to have a parent, and this means that they can be a set of WordPress posts in a tree, each of which has 0 or 1 parents. And here we can use the arrows to point from child to parent, just like this. WordPress, however, does not allow cycles. And for many operations, if WordPress applies a change to a post, it later calls the insert parent post, which traverses the parent post, the post parent post, and so on, until reaching the top of the tree. And this would mean that if the post hierarchy was somehow corrupted and the post graph had a cycle, WordPress could end up in an infinite loop. Loops are bad. And so this is relevant for page hierarchies as well. So if you made a post a parent of itself, it could cause a lot of issues. WordPress anticipated this scenario and added logic for cycle detection. If WordPress detects that there's a loop while updating the post hierarchy, it will update the post parent ID to 0. Ooh, interesting. So rather than just yeeting the post out, it wants to enforce that hierarchy and just arbitrarily assigns the post parent to 0. Oh, okay, so the SSH exploit was client-side. You'd have to have a malicious SSH server. I mean, that's still pretty cool though, Noel, because imagine throwing that sucker up on the internet and letting all that internet background radiation, as I like to call it, come scan your site, and you're just like having shells come to you. It'd be kind of sick. Let's see. So importantly, this call doesn't override the post content. So we can control the post content with the fabricated in-memory posts. Therefore, we can fabricate a legitimate change customization set with JSON associated to the admin user. This allows us to make changes to other posts as the admin. However, once the change to another post is made, our rights revert to those of guest. So how do we go from being able to change the post content to being able to do anything as the administrator? Holy crap, this is so deep. I thought I was the only one who called it internet background radiation. I forget where I stole that term from, Ken. I think it was from one of the blog posts we read on Newsnight, but damn, it's so accurate in there. All right. So here's where the hook comes into play. So to support the rich plugin ecosystem, WordPress has a feature called hooks. And the hooks with names like NQ scripts or publish post allow plugins to hook almost every part of the WordPress lifecycle. Hooks are separated into actions and filters. So for example, a plugin author might want to add functionality to log all user logins and use hooks to do so. Okay, so they've got lifecycle hooks in there that we're using to access everything. The action hooks can also be called manually with a do action. So when logging a user in, rather than just calling some internal WordPress login function, WordPress uses a do action object in here. So this sort of dynamic dispatch is pervasive throughout the code base and was also what makes WordPress so customizable. So when a post gets published, WordPress allows the user to hook that publish event, and they do so by calling the do action in here. So in a legitimate case, this might be the status of a post that has gone from draft to publish, so the dynamic action could be called publish post, and plugins can hook that. Sol realized that that surface is accessible while we have assumed the temporary administrator role. Oh, and realized that because we are fabricating the entire post in memory, new status and the post type can correspond to anything we like and don't necessarily have to correspond to a legitimate post type or status. And that allows us as an attacker to call any action that an administrator can, as long as it contains at least one underscore. That's an interesting requirement, as long as it contains one underscore. So the major problem with the post to ID is that post to ID is under our control, but it's only an ID. Additionally, post is a WP post object. That means that we have almost no control over all the arguments that are provided to the action. Sol again comes up with a strategy to solve this. It targets the parse request hook. This hook is called at the very start of the request lifecycle before almost anything else gets done. The result is that calling parse request will replay the entire batch API request from the beginning, except that now we have our temporary assumed administrator role. Oh no. So that nested batch result that it had in there is now going to be replayed, because in our nested batch results, we're going to have a call that handles how to do this. All right, hold on. This might be two separate calls, but still, that's pretty awesome. All right, so the final exploit makes two requests. Okay, there we go. So that's what we're doing. So first request goes in, fabricates the post in the memory cache. Then the second request comes in and hold on. So the first request sets up all the faking in the memory cache. So we look like we have a legit post happening in there. Then, and also sets up our lifecycle hook for, what was that hook called? Parse request. So it sets up that parse request hook. Then it makes a second request. And then that will fire with all, again, those nested batches, but running as the administrator. So we're going to refer to each post ID we see in our exploit as a single letter, such as C or O. In reality, the letters could be substituted with any ID as long as the ID is high enough to not clash with a legitimate ID already used on the target. Okay, so we're targeting a fictitious post number. So the first request, we see the database with 3 OE embed cache rows for posts O, C, and D. I love that he picked O, C, and D. OCD. So we do this by using SQL injection to return fake posts with ID 0 with the 3 embeddings pointing to S. So we've got something pointing to post S in here. All 3 URLs point to the same S post, but the extra query string but the extra query string token differs. Therefore, they produce 3 different embed cache hashes and 3 different hashes identified as O, C, and D in those rows. Okay. So we're doing this 3 ways here. So for the second request, we need 6 fake posts constructed as follows. So for the O one, we publish the embed cache, empty content, stale timestamp with the parent of the C post. The C post does a customized change set JSON with the parent of C. Then we do the P post, which is put a page into draft with the parent of D. God, this is wild. The D post does a parse request with itself as its parent. Oh. The S request does a publish post for providing the embedding data. And then the T post contains the outer embed. Dude, this is nuts. Oh, I can't open it in the new page. That sucks. Dude, this is nuts. This is a wild path here. Okay, so the forged T-post kicks off execution. It contains an embed to S. So here's our embed to S. Since the request is a local embed with a hash for 0, it calls get post to 0 here. This is backed by a database row, and 0 is embedded back into post S. Okay, so we have T calling S, which is calling O, which brings us back to S. So S doesn't exist in the database, and it isn't a real post, but that's okay, since it's an in-memory post cache that we faked. Okay, not a problem. So the post modify GMT, or due to that fake post modify, we place O. The WordPress believes that the cache of S's data has expired, so it's going to call get post for S, which returns data from the fake in-memory version of S. And that data from S will be transformed by the embedded routine into something suitable for embedding. Dude, this is a wild exploit chain, man. All right. I hope you're tracking this because I'm not. So since O's data has been updated, it will call the following WordPress update post here. Before writing the rows for the O request, WordPress calls the WordPress insert parent filter, and WordPress then discovers that O's parent, C, has a loop in its parent hierarchy. WordPress kicks off some logic that ends up setting that parent post to 0. Bro. The level of hoop jumping here to carry this exploit out is exactly why security teams still have jobs. All those low/dids are going to stack up to this sort of execution. You're not wrong, Rabbit. You're exactly right. Yeah. All those things where they're like, that's a low severity. What are you worried about? I was like, I have personally done exploits where it's like, yeah, by the way, that low and that medium that you said weren't big deals, I combined them together and then Megatron them up into a full code execution. So congratulations. And that was just me working, at good old human speed, let alone these things working at ludicrous speed. All right, so after we now have I chained 8 lows into a high last week easily. Nice. Nice. I love a good exploit chain. Okay, so now what we have done is we're at the point now where C over here was its own parent, but now it's being assigned a parent ID for 0. So C appears legitimate in the database, but in memory, our C is actually the customized chain set, and the fields of C look like this. So post status is future customized chain set, post parent is C, post date is a really old date, and then we have our malicious JSON chain set, and then we have a valid chain set UUID. So when C is being written to the database, WordPress recognizes that the status of the chain set says to be applied in the future, but the date to be applied is actually a date in the past. Therefore, WordPress will move to apply the change set and it will read the change set as create a post with the post data from P, type as an option with user ID 1. The change set is updating a benign setting for P with user ID 1, so WordPress temporarily assumes the identity of the administrator to make this change. P doesn't exist in the database, but it exists in memory as a draft, so that's okay. After applying the change, WordPress makes roughly the following call, where it takes ID P and then publishes it for that post. And using the same cycle gadget, WordPress calls the insert post parent filter and realizes that P's parent, D, has a cycle in its parent hierarchy, so it moves to fix D in the same way. Now, post D has a 0 parent in there. But D isn't a legitimate post at all. In fact, it has a status parse and a type request, neither of which are valid neither of which are valid for normal WordPress. However, WordPress doesn't realize this, and after insertion into the database, WordPress calls the hook for new status and post type, which for D corresponds to parse request. This kicks the whole request into a parsing pipeline This kicks the whole request parsing pipeline off again. But this time, we still have the temporary assumed administrator role. So in the original batch request, it included a request to create a new administrator. This request will fail on the first pass through batch V1, as we're executing it as a guest, but on the second pass, we are the administrator. So the call will succeed and a new administrator account is created. That's wild. Only one person in the galaxy would use raspberry jam. Wait, no, it was it jam? Strawberry. Oh, only one person would dare give me the raspberry. Oh, it's yogurt. I hate yogurt. Sorry. Lone Star. Dude, I hope, supposedly they actually are making a sequel to Spaceballs, and God, I hope it's good. Of course, I always have coffee when I watch Radar. The part where they actually watch the tape of like what's happening so they can fast forward and figure out what to do is so hilarious. Yes, you idiots, I said comb the desert. Man, we ain't found shit. Dude, that was, if you didn't know that, that was the actor who played Tuvok in Star Trek Voyager. And so for like all the stuff he did in Voyager, a lot of folks still just know him as that guy. It's like, we ain't found shit. Oh. All right, let's wrap this one up because unfortunately, damn, we had so much left to go through. That's all right. The news cycle will never end. You're never going to get through all of it. Actually, I put up a post. Hang on one second. I want to show you something I posted up on Twitter. Here we go. Yeah. So this was a thing that Daniel Card, if he's a really cool security guy over on Twitter, super smart guy, showed another AI agent called Agent Zero, and it looks really good. Really cool, really good. I liked it. And so I had to go post this. Like, I see things like this all the time. Yes, they are cool. Yes, they are neat. Everything is moving so fast. Don't let yourself get overloaded. Learn what you need to, learn what you want to, and if you're lucky, most of the time they overlap. You can't learn it all. Enjoy the ride. And I firmly stand by that. Enjoy the ride, guys. Because, like I said, look at all the articles up here. All of these, we didn't get through them all, right? We've been going at this for 3 hours. There's just too much information. Learn how to kind of prioritize and figure out which pieces that you want. All right, let's knock this one out, and then unfortunately we gotta wrap up the stream here. Let's see. So this exploit was produced by Saul in just over 10 hours. So having used every frontier model since the days of GPT in 2022, my belief is that 5.6 represents a significant step up in security research compared to 5.5. When reading through the chain it produced, I was astonished by several creative exploitation techniques that I would previously have thought were only the domain of humans. The use of a recursive batch call to avoid restrictions on GET. The cache abuse to apply a change set and temporarily escalate to administrator. And the choice of a fake post that ended up calling the parse request hook to replay the request with an assumed role. So I make no general claims, but I will say that with complete confidence that no security researcher could have found and completed this exploit chain in 10 hours without AI. 100%. No, this would have been weeks and weeks of work. Even if I gave them the original bug and asked them to exploit it for RCE, I'm not sure it would be possible in that time frame. The ability to spot several disparate gadgets and chain them across a code base is one hallmark of a good security researcher, and Saul does this with inhuman precision and clarity. So as the models get stronger and stronger, it seems like security research will become a bit higher level, deciding what products and services to investigate for how long, steering research directions with prompts, and nudging the language model when it veers off track. So these meta skills are currently still handled quite poorly by AI and will become more and more important as the language model is able to handle the bulk of the technical exploit development work. It's clear that the field of security research is changing rapidly, and I'm excited to see what lies ahead. I am too. In fact, hang on, I need to write something down. Just had an idea. Stand by, guys. Okay. Sorry, I had an idea for something I needed to write down real quick. I gotta go flush it out later. All right, Monkey, you have a great night, man. Yeah, unfortunately, we need to wrap it up there, guys. Thank you all for coming to hang out. Let's see who's on InfoSec streams. Just us. We're the Night Owls. We're the Late Birds. Let's just hope GPT-7 doesn't decide setting off a nuke might increase its test scores. It's going to depend on how much. It's going to depend on, basically, I think it's going to depend on if they gave it a persona where its parents were Asian, then yeah, it might do that. What do you mean you got A-? You got A+. All right, let me go see who we've got up that we can go raid out to. Let's see. Who do we have over in science and technology right now? Let's see. It's 6 a.m. here. I feel more like an old rooster than a night owl. Dude, I am a total night owl. It's very easy for me to just stay up till like 3 or 4 a.m. Let's see. Computer booter is on. Ace console repairs too. Let's see. Oh, actually, you know what? Nerduino's online now. Yeah. I don't see anybody else doing anything really super hacky related. Grim is on. I know he's probably working on Pigeon, but I think we'll go right over to Nerduino. What's he working on? Predatory science journals and how to spot bad science. I mean, that's always a good idea. As much as we would like to believe in like a lot of the scientific integrity, at the end of the day, the scientists have to get funded, and then anytime that's going to happen, you're going to get weird results in there. Wait, hold on. This says Nerduino's offline. Twitch, why are you so dumb sometimes? Hang on, let's go see who we can find in there. Weird that it's saying Nerduino was on. Like, I thought maybe he popped into chat for a little bit to like hang out, and then he went to go start his stream or something. But maybe he came in after he finished his stream. All right, it's still cool to see him. He's like my NASA grandpa I never had. Let's see. Who do we got in here? We might just go right over to Grim. All right, Nelson, have a good night, man. Guys, I appreciate y'all coming to hang out with me. By the way, remember, it's only Wednesday. We still have 2 days of crushing it mode. Let's see. Who are we going to go right out to? It's all right. Let's go right over to Computer Booter. I love seeing, like, the microelectronic works that he's doing. So, yeah, we'll go right over there. All right, guys. Unfortunately, that's where I got to wrap it up. I will catch up with y'all maybe Saturday night. I will let you know for certain on Twitter and Discord. Like I said, I've got a funeral to go to in San Antonio, and that's on a good day a 4-hour drive, on a bad day a 5.5 hour drive. So I just don't know what's going to happen Saturday. I'm probably leaning towards it won't happen, but I will let you know for certain over on Twitter and Discord. Oh, sorry. Yeah, Twitter and Discord. But I want all y'all to have a fantastic rest of your week. Remember, we had 2 days of Crushing It mode left. Friday is read-only Crushing It mode, especially if you value your weekend. And do me a favor, when you go over to Computer Booter, drop a bunch of happy hackers in there. Show them some love. I love seeing the microelectronics, especially considering the repairs I've got to do to the main board in the chiller here at the house. That's going to be a lot of fun. I got to learn electronics now. But anyway, guys, that's all I got for you. I want you to have a good week. Awesome. Really, you're all awesome. I love you guys. I really like doing the live streams and coming to hang out with everyone. You guys are great. I will catch up with y'all possibly Saturday, definitely Sunday. And I want y'all to remember one very important thing, and that is I love you. Peace.